right, well, we'll go ahead and get started now. Hello, everyone, and welcome to the second annual Cancer Wellness Symposium hosted by LifeOmic and Karuna Precision Wellness Center. My name is Julia Holbrook, and I'm the Executive Director of Karuna Precision Wellness Center. We are thrilled to partner with LifeOmic to bring you today's keynote speakers who are well known in their fields and have vastly contributed to advancing research. Dr. Michael Greger, Dr. Kathryn Schmitz, Paul George, Dr. Anthony Magliocco, Dr. Jamie Renbarger, and Dr. Donald Brown. First, some housekeeping. There will be a 5-minute break at the end of each presentation, so you can plan to have a few minutes to step away from your computer. Second, we will be taking questions throughout the day to address at the end of each session, so you may submit your questions in the Q&A box at the bottom of your screen. Please note we will show an 8-minute video of Dr. Greger's followed by 30 minutes of Q&A with him. Finally, we will be sending a short survey after the symposium and appreciate your feedback. You will also be receiving a recording of today's presentations. Now I'd like to introduce you to my colleagues, Dr. Jamie Renbarger and Dr. Donald Brown. Dr. Renbarger is founder of Karuna Precision Wellness Center and Division Chief of Hematology Oncology at Riley Children's Hospital. Dr. Renbarger is also a physician scientist at IU School of Medicine with an interest in personalized medicine. Her area of expertise is in pharmacogenomics and the treatment of childhood cancers. Pharmacogenomics is the study of the role of the genome in drug response. Dr. Renbarger and her team have successfully used this approach to identify the genetics of tumors in children to optimize their treatment and increase long-term survival. Dr. Renbarger's strong interest in survivorship care for pediatric cancer patients recently led to her founding the Karuna Precision Wellness Center to help patients and survivors enhance their quality of life. I'd also like to introduce you to Dr. Donald Brown, LifeOmic's founder and CEO. Dr. Brown is the most successful serial software entrepreneur in the Midwest, having created and sold several highly successful tech companies. Don is a technology and business advisor, investor, and philanthropist. His latest venture, LifeOmic, brings technology and precision health together with innovative cloud and mobile software. Welcome, both of you.
Thank you.
Thanks so much, Julia. All right, so I will start. I have a couple slides to share, and then Don, I'll pass it over to you after that.
All righty.
Let's see what I got here. All right. So first of all, thank you to everybody for taking the time and having the interest in checking out our symposium this year. As Julia mentioned, this is our second annual symposium. And this is all really grounded in our passion for health and wellness, and in this setting around personal wellness for people impacted by cancer. Julia mentioned sort of some of the different hats that I wear, and I think at my core, I'm really passionate about helping people and specifically those impacted by cancer to live their best lives and to be successful in achieving their goals, regardless of where they are in the cancer journey, and in helping them to do those things. So Karuna really, I think, stemmed from this passion for looking at ways to bring together integrative health and wellness with medical care to really help people in living healthy lives through and after cancer treatment. I think I'm also privileged to not only have roles within Karuna and at IU School of Medicine, where I've spent my entire academic career, but also recently over the last few years to develop an incredibly exciting partnership with LifeOmic, where I serve as an oncology advisor in really finding ways to help in creating software products that meet the needs of people impacted by cancer. So at Karuna, our goal is really improving health and wellness for individuals any individuals impacted by cancer across the United States through innovative care, and specifically in finding ways to integrate different care modalities to really create personal wellness plans for individuals. We're also committed to providing data that this approach works and can benefit individuals, such that ultimately insurance companies and others may bring that into the fold of care and services that they cover for individuals, and ultimately in educating current and future caregivers and leaders in what we feel like is a really rapidly expanding field. I'm going to switch to slideshow mode. There we go. I know we have a really diverse crowd attending today, but as I think many of you know, the great news is that we cure a lot of people with cancer, both across pediatrics as well as within the adult arena. And in fact, the death rate from cancer has decreased significantly over the last 20 to 30 years. What that translates to is over 20 million cancer survivors in the United States today. The bad news on the right, some of this is really represents part of the spectrum of side effects that people can, or side effects of treatment, as well as the impact of cancer itself, specifically on different body systems. What we know beyond this, though, is in fact that the risk for things like obesity, cardiovascular disease, metabolic syndrome, type 2 diabetes, and a host of other significant chronic health conditions is pretty significantly increased among people who have been impacted by cancer. And so our goal is not only to help individuals in dealing with some of the direct treatment effects, right, like neuropathy or chemofog, fatigue, but also to help in decreasing risk for some of these really life-threatening long-term health conditions. I think as an oncologist who has become increasingly passionate over time about survivorship care and about really meeting individuals where they are, and never allowing them, or our goal is really to never allow them to feel alone or as if cancer treatment has ended and so they're sent off to live life and figure things out, but to really help them in feeling cared for and embraced. And the medical care, I think that many programs provide for individuals as they're making that transition can be quite good. And the reality is that there's so many opportunities to really optimize health and wellness after treatment. And that's really our goal, is to look at the whole person at Karuna, and to systematically evaluate them, gather information about that individual, their treatment, and what their long-term goals are, as well as risks from family history of certain chronic health conditions, and to really develop an integrated, comprehensive plan addressing not only physical functioning and wellness, but also nutrition, psychosocial and emotional wellness, and cognitive wellness. Again, with the goal being that everyone can live their best lives and to remain healthy and productive for as long as possible. So in a nutshell, that again is where we're coming from in terms of Karuna. I think one of the things that Don and I and so many others from both groups, both LifeOmic and Karuna, have really appreciated particularly over the last couple of years during the pandemic, is ways that through our partnership that we can reach even more people and hopefully have a dramatic impact on the whole cancer continuum. So with that, I'm going to pass things over to Don, and I'm super excited for the day, and thanks again so much for participating.
Thank you, Jamie. I just want to say that it's an honor to be associated with Karuna. The mission that you guys have taken on is a really important one. And I think it's quite true that for cancer survivors, they can often feel pretty alone after, there's a kind of victory party that you sometimes get to have to say that, we've beaten the cancer or in remission, but there's so much to the journey after that. And that part really hasn't gotten much attention to date. So it's great to see Karuna start to change that situation. So what I'll do is just tell a little bit about LifeOmic. We're about a 100-person company headquartered in Indianapolis with offices in North Carolina and the Salt Lake City area in Utah. And we started off working with my alma mater, the IU School of Medicine, to build a platform that could provide a repository for all healthcare information and ultimately help researchers and clinicians diagnose disease and optimize treatment. And we've really moved beyond that to focus more on the patient side of the equation, because as this little slide illustrates, so much more of our outcome, our health is determined by factors outside healthcare than by the healthcare system itself. And especially our individual behavior, what we eat, how much we exercise, what we do has a huge influence on our health, along with social and environmental factors, and to a lesser degree, the genes that we were born with that are important, but usually are not deterministic. And so we've created a cloud platform called the Precision Health Cloud that's in use at Indiana University Health for cancer patients that allows researchers to collect all these different types of information, whether they come from electronic medical records or the fancy whole genome sequences that I'm sure you've heard talk about that give us information about a person's DNA. And then we really try to use that platform across the whole continuum because we're as much as anything, we'd like to try to prevent cancer and diagnose it early. But then we want to treat it effectively and then work on survivorship. And it's kind of at those two ends that they wrap back together. The same factors involved or important in prevention also play a big role in survivorship. And so we want to work to move more outside the healthcare system to empower people to do more on their own because so much of their lives is really outside the hospital or the clinic, and all these other behaviors play just a critical role. So what we've done is to develop a mobile app that runs on both iOS and Android that allows clinicians to stay connected in real time with patients, because as you all know, these days we're all on our phones. Just look at any restaurant or public transit and you'll see, sadly, many drivers as well. But we've tried to create a mobile app that provides all these sorts of functionalities in a clinical setting so that a clinician can send out surveys, get consents, and more than anything, try to educate patients as to the things that they can do to improve their lives, improve their health, to prevent disease when possible, to help people recover from cancer and other conditions once they've suffered from those. But incorporating the latest technology with audio, video, and all those sorts of things in a very secure manner. And this is just a little illustration of the app. We actually have about 3.5 million people around the world already using it. And it focuses on, and really overlaps quite a bit with what Jamie talked about in terms of health priorities, exercise, nutrition, sleep. We're big believers in taking a break from food once in a while. So intermittent fasting and mindfulness, and syncing with the many wearable devices out there like Apple Watch and Oura Ring and others. We believe there's a strong social component to health, and especially with something like cancer survivorship. So we've built really strong social interaction capabilities into our app so people can create and join communities of people with similar concerns. And then we've incorporated just a bevy of highly respected educational resources from leading institutions. And so overall, what we're trying to do is to bring these notions of precision health to wellness for both individuals as well as corporations. And it's just an exciting time because technology can play such a big role. I think we've all seen that technology can do bad things. Technology can split us apart in so many ways, especially on social media, but it has the potential to do so much good. And at LifeOmic, that's what we're dedicated to, trying to realize the positive things that can result from technology to improve our lives, help people understand how they can impact their health. And certainly cancer has been kind of at the center of what we've done from the beginning of the company. So it's exciting to work with Jamie and Karuna to see what we can do to improve the situation.
Great, thank you both so much. We do have some time here for questions from the participants. I do see one here down at the bottom that I'll go ahead and read, and I'll let both of you chime in on an answer. And then if anybody else has any questions, please type them in at the bottom of your screen there in the Q&A box. So this is from someone from Bangladesh. He's the founding president of cancerbd.net, a cancer awareness website. His question is, here in Bangladesh, our healthcare system is too poor, and then when it relates to cancer, it's even worse. Please suggest the main three things we should follow to ensure a better oncology healthcare. As an awareness advocate, what are you going to suggest to us to advocate to the nation's health policymakers? It's kind of a big one.
That is a very big one. Jamie, you want to take a crack?
Wow. I really appreciate that question. And, I've done a bit of work in both South America and Africa in collaborating really to help in providing cancer care for individuals in developing countries and in resource limited settings. And while it's a challenge, I think certainly, it's doable. In terms of the question itself, and in advocating and in thinking about policy, my first thought goes to prevention and thinking about approaches to really decrease risk for cancer. In that, I think I think that in terms of limited resources, that is a way to help in saving money by preventing cancer altogether. And so things like, in terms of thinking about our cancer prevention opportunities, things like having a healthy diet, and doing things to decrease inflammation in the body throughout the course of one's life. Looks like there was just a comment in the chat about, prevention and awareness is imperative. In terms of really any inflammatory process, particularly in the United States, that includes things like obesity and having a healthy diet, avoiding things like smoking, are really some of the key factors in terms of prevention. And so, I know that from a policy perspective, one opportunity is to really put resources into that space. Don, anything you would want to add? I'm sure you've got.
Yeah, it strikes me that some of the really all the things that you mentioned really go right through the continuum. I'm sure when you see cancer patients, you give them a lot of the same advice, right? To try to change their diet, certainly to stop smoking if they are, to practice mindfulness and get more exercise. And I think one interesting way to frame the question would be, if people could not get cancer treatment at all, if you had cancer and could not get treatment from a healthcare professional at all, what would you do? What could you do on your own? And I have a hunch it goes back to those same factors, that you would try to lose excess weight, you would try to decrease the amount of inflammation in your body, in your environment. You would start with your diet and try to adopt an anti-inflammatory diet. Try to exercise more, practice mindfulness. So I think we have to think about things that, especially in these situations and where there isn't, where the healthcare system is not very available and maybe not very mature, to think about what people can do on their own, because that's the situation they're going to be faced with. But then I agree, in terms of national policy, to some extent, we've got the same problem here in the US. There just needs to be more focus on prevention, because cancer is preventable to a large degree. Our behaviors have a huge impact on our probability of developing cancer and the course of that cancer.
Thank you. We do have a question about, how does a patient connect with you? We're located, Karuna Precision Wellness Center is located in Indianapolis. Many of our services are available virtually online. Like everybody else, we got that up and running during the pandemic. But our website is karunaprecision.org. If anybody would like to connect with us, our contact information is there.
And I would add to that, I think one of the exciting partnerships that that LifeOmic and Karuna are creating really is opportunities to autonomously participate in both an introduction to sort of foundations of health and wellness during cancer treatment, as well as a cancer wellness program, which are not available yet, but are tools that we're really aiming to launch in the near future. So stay tuned on the LifeOmic page for that as well.
Thank you. Do we have any other questions for Dr. Brown or Dr. Renbarger? Okay, can you see that, Jamie, or I see you shaking your head? The question here, I believe, is only available to the panelists. So this is limited resources in cancer prevention, adequate folate, Protecting against DNA strand breakage, especially greens, plant foods, would be near top of my list. As a physician working with prevention for a long time, that means investing in access to fresh green goods or foods may be difficult in poverty, especially urban areas.
Yeah, it's a great point, Candace. At least here in the US, it's a shame that we don't just have bins of fresh produce for free in poor neighborhoods. I mean, imagine with the agricultural capacity of this country, it would be a trivial cost for us to take just blemished, fruits and vegetables, the kinds that, are perfectly good, but the grocery store won't sell. They should be free in poor areas. That's just such an easy thing that we could do, and to really try to encourage the consumption of real food, of real healthy plants. I'm a huge advocate. I don't know what Jamie has to say.
No, absolutely. Absolutely. Right. Access, I think easy and free or very inexpensive access to healthy foods, I think is critical.
Yeah,
We see that in some, oh, sorry, Dr. Brown.
I was just going to point out that, right now, the financial incentives are just so crazy. Because as a poor person, if I'm trying to feed my family and I've got $10, I can go to McDonald's and get 100,000 calories or whatever that would be. And, calorically, I can satisfy the need of my family for very little money. But for me to do that with organic vegetables and, high quality produce, it would cost me an arm and a leg, to go to Whole Foods and try to do that. So we've got to figure out how we change those financial incentives instead of working against them, because that doesn't work.
Mm-hmm.
Yeah, I think we need to do that on the agricultural level too, right? Because most of the agriculture in the United States is corn, wheat, and soy. Yep. And we see that in some urban areas where they convert pieces of land into communal gardens that anyone can come in and pick produce. But I think we need obviously to see that on a much larger scale. Yeah,
it's one of the simplest, cheapest things we could do that would make an enormous difference.
Mm-hmm. Okay, if we don't have any other questions, I think we'll go ahead and wrap up and move on to our next speaker. So thank you very much, both Don and Jamie, for joining us this morning. I'm sure you'll be sticking around for our other speakers. And next we have Dr. Michael Greger, who I'm so excited to introduce. And so we'll go ahead and get started with Dr. Michael Greger. So I have the distinct honor of introducing you to Dr. Michael Greger, a founding member and fellow of the American College of Lifestyle Medicine, physician, New York Times bestselling author, and internationally recognized speaker on nutrition. Dr. Greger has videos on more than 2,000 health topics freely available at nutritionfacts.org, with new videos and articles uploaded almost every day. Dr. Greger has lectured at the Conference on World Affairs, testified before Congress, and was invited as an expert witness in the defense of Oprah Winfrey in the infamous Meat defamation trial. He is a graduate of Cornell University School of Agriculture and Tufts University School of Medicine. 3 of his recent books, How Not to Die, the How Not to Die Cookbook, and How Not to Diet, all became instant New York Times bestsellers. His latest 2 books, How to Survive a Pandemic and the How Not to Diet Cookbook, were released in 2020. All proceeds he receives from the sales of his books go to charity. So we will first watch an 8-minute video entitled How Not to Die from Cancer, followed by 30 minutes of Q&A with Dr. Greger. So please use the Q&A box down there at the bottom of your screen if you have any questions that come to mind while we're watching the video, and then we'll address them after it's complete.
After Dr. Dean Ornish conquered our #1 killer, he moved on to killer number 2. What happens if you put cancer on a plant-based diet? Ornish and colleagues found that the progression of prostate cancer could be reversed with a plant-based diet and other healthy lifestyle behaviors, and no wonder. If you dip the blood of those eating the standard American diet onto cancer cells growing in a petri dish, cancer growth is cut down about 9%. Put people on a plant-based diet for a year, though, and their blood can do this. The blood circulating within the bodies of those eating plant-based had nearly 8 times the stopping power when it came to cancer cell growth. Now, this was for prostate cancer, the leading cancer killer specific to men. In women, it's breast cancer, the #1 cancer killer of young women. So researchers wanted to repeat the study with women using breast cancer cells instead, but they didn't want to wait a whole year to get the results. Women are dying now, so they figured, let's see what a plant-based diet can do after just 2 weeks against 3 different types of human breast cancer. Cancer growth started out powering away at 100% and then dropped after eating a plant-based diet for 14 days. Here's the before picture. A layer of breast cancer cells is laid down in a petri dish, and then blood from women eating the standard American diet is dripped on them. And as you can see, even the blood of women eating pretty poor diets has some ability to break down cancer. But after just 2 weeks eating healthy, blood was drawn from those same women, so they acted as their own control. Same women, 2 weeks later, their blood dripped on a new carpet of breast cancer cells, and this is all that's left. Just a few individual cancer cells remain, their bodies cleaned up. Before and after, just 2 weeks eating healthy, their bloodstream became that much more hostile to cancer. Slowing down the growth of cancer cells is nice. Getting rid of them is even better. This is what's called apoptosis, programmed cell death. After eating healthy, their own bodies were able to somehow reprogram the cancer cells, forcing them into early retirement. This is what's called tunnel imaging, measuring DNA fragmentation, cell death. So dying cancer cells show up as little white spots. So again, this is the before, what the blood of your average woman can do to breast cancer cells. She can knock off a few. You can see one dying cancer cell there in the upper left. But then after 14 days of healthy plant-based living, her blood can do this. It's like you're an entirely different person inside. The same blood now coursing through these women's bodies gained the power to significantly slow down and stop breast cancer cell growth after just 2 weeks eating a plant-based diet. What kind of blood do we want in our body? What kind of immune system? Do we want blood that just kind of rolls over when new cancer cells pop up? Or do we want blood circulating to every nook and cranny in our body with the power to slow down and stop it? Now, this dramatic strengthening of cancer defenses was after 14 days of a plant-based diet and exercise. They had these women out walking 30 to 60 minutes a day. Well, if you do 2 things, how do you know what role the diet played? So researchers decided to put it to the test. This is measuring cancer cell clearance, is what we saw before. The effect of blood taken from those who ate a plant-based diet, in this case for an average of 14 years, along with mild exercise, just like out walking every day. Plant-based diet and walking, that's the kind of cancer cell clearance you get. Compare that to the cancer-stopping power of your average sedentary American, which is basically non-existent. This middle group, though, instead of 14 years on a plant-based diet, 14 years standard American diet, but 14 years of daily, strenuous, hour-long exercise like calisthenics. The researchers want to know, if you exercise hard enough, if you exercise long enough, can you rival some strolling plant eaters over there? And the answer is, exercise helped, no question. But literally 5,000 hours in the gym was no match for a plant-based diet. Same tunnel imaging as before. Even if you're a couch potato, eating fried potatoes, your body's not totally defenseless. Your bloodstream can kill off a few cancer cells. But exercise for 5,000 hours, you can kill cancer cells left and right, but nothing appears to kick more cancer tush than a plant-based diet. We think it's because of animal proteins, meat, egg white, and dairy proteins, increasing the level of IGF-1 in our bodies, insulin-like growth factor 1, a cancer-promoting growth hormone involved in the acquisition and progression of malignant tumors. Here's the experiment that really nailed IGF-1 as the villain. Same as last time, go on a plant-based diet, cancer cell growth drops, cancer cell death shoots up. But then here's the kicker. What if you add back to the cancer just the amount of IGF-1 banished from your body because you started eating healthier? It effectively erases the diet and exercise effect. It's like you never started eating healthy at all. So the reason one of the largest prospective studies on diet and cancer found the incidence of all cancers combined was lower among those eating more plant-based, maybe because they're eating less animal protein, less meat, egg white, and dairy protein, so end up with less IGF-1, which means less cancer growth. How much less cancer? Middle-aged men and women with high protein intakes had a 75% increase in overall mortality and a 4-fold increase in the risk of dying specifically from cancer. But not all proteins, specifically animal protein, which makes sense given the higher IGF-1 levels. The academic institution sent out a press release with a memorable opening line: "That chicken wing you're eating could be as deadly as a cigarette," explaining that eating a diet rich in animal proteins during middle age makes you 4 times more likely to die from cancer, a mortality risk factor comparable to smoking cigarettes. What was the response to the revelation that diets high in meat, eggs, and dairy could be harmful to health as smoking? Well, one nutrition scientist replied that it was potentially dangerous to compare the effects of smoking with the effects of meat and dairy. Why? Because the smoker might think, why bother quitting smoking if my ham and cheese sandwich is just as bad for me? So better not tell anyone about the whole animal protein thing. That reminds me of a famous Philip Morris cigarette ad that tried to downplay the risk by saying, hey, you think secondhand smoke is bad, increasing the risk of lung cancer 19%. Well, hey, drinking 1 or 2 glasses of milk every day may be 3 times as bad, 62% higher risk of lung cancer, or doubling your risk frequently cooking with oil, or tripling your risk of heart disease by eating non-vegetarian, or multiplying your risk 6-fold by eating lots of meat and dairy. So, they conclude, let's keep some perspective here. The risk of lung cancer from secondhand smoke may be well below that of other everyday activities, so breathe deep. It's like saying, don't worry about getting stabbed because getting shot is so much worse. Right? How about neither? 2 risks don't make a right. Of course, I know Philip Morris stopped throwing dairy under the bus once they purchased Kraft Foods. Just saying.
I always enjoy watching that video, Dr. Greger. It's very informative. Thank you for joining us today.
I could have just done it live, but all right, that's good.
So I'll kick off some of the questions while we wait for some more to come in. But I just want to say again, I am such a fan of yours. I watch your weekly videos on all manner of subjects, and I'm just so thrilled to have you here with us today. So thank you very much.
I am happy to be here. Let's do it.
Okay, so first question here, have you seen any studies that show an impact of plant-based diets and intermittent fasting combined on fighting cancer cells?
Yes, not just fighting cancer cells, but actually fighting cancer. So there's 2 case reports published in a prestigious journal called the BMJ Case Reports. This is the True North Health Center in California. Where are they? Kind of Northern California. They were able to reverse a, what was it? I think it was what kind of lymphoma was it? I think it was a follicular lymphoma. If I remember correctly. I have some videos coming up about it. They're not up yet. So this was water-only fasting followed by a whole food plant-based diet. I had these huge tumors dissolve away and stay away for years. That was super exciting. There's all sorts of reasons that could happen. Of course, you can never rule out with case reports just spontaneous regression, where cancers just go away for no reason. And so you ascribe some kind of cause and effect. Oh my God, I'm so glad I ate that dog food yesterday because look, my cancer went away. I mean, you never know what exactly it does until you put it to the test. But that That's the only, I'm trying to think if there's any other fasting. That's the most exciting fasting data, but recognize, fasting by definition is unsustainable. In fact, it's probably the most unsustainable diet, because you stick with it long enough, then you die, 100% fatality. So the question is, well, wait a second, what happens? What kind of diet do you go back to? And so all these amazing studies that show that fasting can reduce your blood pressure and reduce inflammation, rheumatoid arthritis, etc. You only lock in those benefits if you then don't go back on the diet that caused those problems in the first place, right? If you go back to eating the same stuff, you can get the same diseases. So then so I view fasting as a way to kickstart healthy eating, but no reason to do the fasting step. You can go straight to healthy eating tonight at dinner time.
Very good, thank you. You had mentioned the study that details the impact of eating animal protein for middle-aged men. Is there research that shows similar benefits for younger populations not eating animal proteins? Does age matter to reap the benefits?
And so that was for both men and women, but indeed middle age, I believe 45 through 60. In terms of, we have epidemiological studies like the Harvard Nurses Health Study, although that was older too. I'm trying to think, younger studies. Most, because, they actually want a large number of disease endpoints. So we tend to study older populations, young protein in young folks. I mean, you can look at short-term biomarker changes. So the reason, for example, we think animal protein increases risk of cancer, one of the reasons is the increase in IGF-1 levels, this cancer-promoting growth hormone. And that same effect happens in young folks and old folks. You can add animal protein, remove from their diet, and see IGF-1 levels go up or down. Now, we would presume that translates into increase or decrease cancer risk, but do we have a study where we followed large numbers of young people along to see if that was the case? I'm not aware of any.
Okay,
it's kind of similar with like heart disease, right? Heart disease is such a rarity among young people. You can't see a lot of heart attacks, but what you can see is changes in heart attack risk factors. So changes in blood pressure, changes in cholesterol. And so these are kind of intermediate risk factors, not disease endpoints, but since we know LDL cholesterol, for example, is leading risk factor for heart disease or number one killer, anything makes your LDL go up, increase your risk of heart disease, anything makes it go down, decrease your risk of heart disease. And so, you can use that. So you can use these short-term studies to then kind of project out what that would mean for disease risk.
It kind of along those lines too. What about children? There isn't a lot of information about pediatric cancer patients and nutrition. Do you have any input on that? We get that question a lot here.
So we certainly have, we have the Belagosa heart study looked at accident victims of young children. So after the Korean War, we saw all these autopsies of young men aged 23 ravaged by heart disease, which we thought was something that only happened later. And that led these researchers in the South to say, well, wait a second, how early does this go? And found that by age 10, all kids, 100% of the kids they looked at who tragically died in car accidents or whatever, already had what are called fatty streaks building inside their arteries, which is the first stage of the disease, then turn into plaques in our 20s, get worse in our 30s, and then can start killing us off in our 40s. So it's never too early to reverse heart disease, never too late to reverse heart disease. Most of the Ornish studies, which reverse heart disease, done with people in their 60s and 70s, so their whole lives eating unhealthy, and then within a few months, able to start to see regression. So in terms of trying to say, and so there's a lot of childhood obesity literature talking about diet improving abdominal adiposity, but in terms of We don't see much in terms of cancer, again, just because the rates tend to be so low. I mean, we do have, the childhood cancer studies that are out there, the population studies are with what pregnant women are eating and the subsequent risk for the children. So they don't actually see what the kids are eating, but there are studies showing that, for example, women that eat processed meat, bacon, and hot dogs, lunch meat, have increased risk of their children getting childhood brain tumors or something. Now, is that possible just because, there's lots of processed meat in the house and the kid was eating it as well, and that had nothing to do with the pregnancy, though that's more difficult to tease out. But yeah, most studies with childhood cancer are done with kind of perinatal maternal consumption.
Okay. And so what about, anyone who watches your videos knows that you support plant-based diets. Are those safe for children as well? It sounds like what you were just talking about as far as heart disease.
Yeah, no, absolutely. Right. No, a healthy diet is a healthy diet at all stages of the life cycle. So the largest and oldest association of nutritional professionals in the world, American Dietetic Association, which is now the Academy of Nutrition and Dietetics, their latest position paper on plant-based diets, as well as every single position paper they've ever done on plant-based diet, say that even strictly plant-based diets are not just appropriate for all stages of the life cycle from pregnancy, infancy, on through old age, but actually have these advantages in terms of chronic disease risk, as our leading killers are diet and lifestyle related, such as heart disease, diabetes, type 2 diabetes, high blood pressure. These can be not just prevented and arrested with the plant-based diet, even reversed with healthy enough eating. So this is healthy eating regardless. There are certainly some tweaks has to be made. For example, children's tummies are so tiny that they have to have very nutrient dense foods. They fill up with salad before we got enough calories into them. And on a per weight basis, they actually need more calories because they're actively growing. And so you're thinking about really nutrient dense foods, nut and seed butters and avocados and smoothies and all these things really pack a lot of nutrition and calories in, but same diet, just more concentrated.
Yeah, and I think a lot of people think if they don't eat meat and they're eating, plant-based burgers and things like that they're eating healthy. Do you have any thoughts on that?
They're eating healthier. Absolutely, right? Zero cholesterol, tends to be less saturated fat, actually has some fiber. So healthier, absolutely. But you can actually make your own bean burgers, and then it's actually made out of whole plant foods and not just some kind of processed protein concentrates. But even the protein concentrates lower your cholesterol and do beneficial things. But ideally, we should not just eat a plant-based diet, but a diet centered around whole plant foods. Try to stay away from the processed stuff. But again, even the processed stuff is healthier.
Okay, great. Thank you. We had a question from the audience. What duration of intermittent fast do you recommend?
If you look at my, this is 3 books ago now, my How Not to Diet, I have the biggest chapter is fasting, just intermittent fasting. Just there's so many different types. There's the alternate day fasting, 5-2 fasting, 25-5, time restricted feeding, on and on. And I talk about the pros and cons of each of them. And basically, bottom line is, I think something like alternate day fasting actually has negative consequences, at least for women long term, in terms of raising cholesterol. Versus the same amount of calorie restriction on a chronic day-to-day basis. So I would recommend against that, or at least if you do that, even though that hasn't been shown to have any advantages, to make sure you get cholesterol checked. But early time restricted feeding is where the data pans out, meaning that we should try to extend our daily fasting window 12 hours or more. And ideally, it should be early rather than late. So if you're going to skip any meal, you'd be skipping supper, not breakfast. We should try to shift our caloric intake more towards the morning. So big breakfast. That's the way, because calories in the morning actually don't count as much and don't cause us high blood sugar levels. And we were not meant to eat after sundown, so I encourage people to fast after 7 p.m. every day.
Interesting, thank you. Let's see, I have a question here. The study you presented showed the impact of 3 conditions on killing cancer cells: control, exercise, and plant-based eating plus exercise. How does plant-based diet alone compare to these groups?
So there, I'm trying to see if there's been, well, so, I mean, you could compare the plant-based eating group plus the plant-based eating and exercise group versus exercise group. And you could estimate that, everything above what you see from the exercise will be attributed to the plant-based diet. But it's more than that, actually, because it was a very rigorous exercise group and a very unrigorous, so we're talking about doing vigorous exercise versus in the plant-based group, they were just out walking every day. So you'd actually get more, one would presume, because vigorous exercise is healthier than moderate walking, we would assume that's actually a bigger. I'm trying to think if that's actually been, if we've, that's been tested in terms of cancer. Yeah, so the Ornish study that actually showed the reversal of prostate cancer, the first study showed that a diet and exercise, actually lifestyle changes are reversing the progression of cancer. That did include a walking component. So we don't know if we would have got those same, although actually they actually didn't change their exercise. That's a good point. So they were told to exercise, but they actually didn't. But they were told to eat healthier and they actually did. So I guess even though the study was designed with an exercise component, they didn't actually end up significantly exercising more than the control group. So you really could attribute those benefits to the dietary component.
Very good. I wanted to throw in a question here for you. I watched your video. It was actually a Q&A session you did with a group. They may have been a group of vegans, but you were talking about cruciferous vegetables. You've talked about that in several videos and the impact that they have on fighting cancer. Can you talk a little bit about that in addition to the preparation of them? Because I think that's something that most of us don't know as well.
Oh, yeah. So cruciferous vegetables, these are cabbage family vegetables. So we're talking about kale, collards, cabbage, broccoli, Brussels sprouts, a lot of the Asian vegetables like pak choy and bok choy. So these are not just dark green leafy vegetables, which are not only the healthiest types of vegetables, the healthiest food on the planet. There's more nutrients per calorie in greens than anything else. So we should eat greens every day. And then on top of that, so my daily dozen checklist of all the things I encourage people to fit into their daily routine, available as a free app, iPhone, Android, called Dr. Greger's Daily Dozen. I don't just have a greens category, but then a specific separate cruciferous vegetable category, which there's some crossover, but something like cauliflower is cruciferous, but not a dark green leafy vegetable. It is one of the rare food groups on the planet. In fact, there's only 2 foods that actually have what's called these so-called glucosinolates compounds, cruciferous vegetables, in this moringa tree, which grows in Africa. And what they do is they have these anti-cancer compounds. And so, for example, women with lung cancer is actually the #1 cancer killer of women, not breast cancer, who eat cruciferous vegetables live significantly longer than those that don't. We see the same thing with bladder cancer. So not only prevention, but survival. And sulforaphane, which is the active compound in this vegetable family. And again, unique to this vegetable family, you're just not going to get it eating vegetables in general. It boosts the detoxifying compounds in the enzymes in your liver, these phase 2 enzymes. So if you have a big plate of broccoli, you actually have to drink more coffee to get the same caffeine buzz because your liver is souped up in its ability to detoxify. But that's great if you're going on a barbecue or something and you're going to be exposed to, these polycyclic aromatic hydrocarbons from barbecued meat. You actually have less flowing through your body if even a week before you ate broccoli. So there's, and the same, we see the same thing with smokers. Eating broccoli reduces the amount of carcinogens flowing through their bodies because it just increases your detoxification mechanisms. Same thing happens in our lungs. Have detoxifying enzymes. You can, which is certainly useful during these times. You can drip influenza viruses in people's noses, randomized to either eat broccoli sprouts, which are cruciferous, versus alfalfa sprouts, which are not, have significantly lower virus-induced inflammation, significantly lower viral counts, meaning boosting your body's ability to destroy the virus, increasing natural killer cell activity, which not only destroys virus-infected cells, but also cancer cells. In the broccoli sprout group compared to the alfalfa sprout group. So all sorts of benefits for eating cruciferous vegetables. And then the question you asked is exactly how do you prepare them? It's actually a little complicated. And I could go into it. It's really fascinating. So there's actually no sulforaphane, which is this magic compound I've been talking about in broccoli. It's actually produced by a precursor compound when the cell walls are burst open, like a chemical flare reaction. And so that happens when you chew them. Unfortunately, the enzyme that makes that happen is destroyed by cooking, but not the precursor. So what we have to do is pre-chop our vegetables and then wait 45 minutes. So you chop your broccoli. So if you're going to make broccoli soup, what normal people do is they cook the broccoli and then they blend it up. You can't do that because then you're going to destroy the enzyme and make no sulforaphane. So what we do is you chop the broccoli and then you cook it, and then all the sulforaphane is made and it's heat stable. You don't have to worry about cooking. So either eat raw cruciferous vegetables or wait 45 minutes, or there's a third way you could do it, is you could actually add the enzyme itself, which is found in mustard powder, because mustard powder is mustard seeds and mustard greens are cruciferous vegetables. So the enzyme is actually found in dried mustard powder you get at the store. You can sprinkle that on cooked greens and then you don't have to wait, and because then you add the enzyme, you make the sulforaphane, it happens in your stomach. So anyway, yeah, you want to maximize the benefits, hack and hold, eat raw, or sprinkle some mustard powder, or some radish. That's cruciferous vegetables as well, or raw, dark green leafy. So if I don't have time to, chop my kale or chop my broccoli, and I'm in a rush, I can cook the broccoli and then add just some sprinkle some raw arugula on top. And the arugula, the enzyme in the arugula will attack the glycosylate in the cooked broccoli, make the sulforaphane, and you are good to go.
Very good. We had a question here, but what about marine greens? Are they as good as cruciferous?
Oh, what a great question. Marine greens are not as good as cruciferous, but they are as good as terrestrial greens and actually have benefits, particularly in terms of trace minerals. So they are the most concentrated source of iodine on the planet, which is a necessary mineral. So yeah, that is why I snack on nori sheets, like the sushi sheets. You can eat them like snacks. They have all sorts of, sugar, salt added seasoned ones, but no, you can just take raw nori, chew on them like snacks. Kids love them. My dogs love them. And then, so it's a great source of iodine. My only caveat would be stay away from hijiki, which has too much arsenic. It's so good at picking up minerals. It actually picks up arsenic straight from the ocean. And then kelp has too much iodine. And unless you're doing minuscule doses, you actually get too much and trigger something called a thyroid storm or hyperthyroid reaction. And so so I encourage people to stay away from kelp unless you're doing really small quantities.
Yeah, if someone were just starting out, Dr. Greger, maybe newly diagnosed with cancer or wanting to reassess where they are with nutrition, what would you suggest they start? Because everything that you're talking about today can be a little bit overwhelming when you've never heard it before.
Totally. So the cancers are different. So some cancers are affected by some foods and not others. And so I would encourage is once you have a diagnosis to go to Nutrition Facts and type in your particular cancer. And so what do you do for lung cancer is different than what you do for breast cancer. And what you do for estrogen receptor positive breast cancer may be different than what you do from estrogen receptor negative breast cancer. And see which foods. And one of the principles of the American Institute for Cancer Research, which is kind of like the leading institution for diet and cancer, is that the same diet and lifestyle choices that prevent cancer are the same ones you use to treat it. And that's because it's really an artificial separation between prevention and treatment, because we act as though we get cancer the day we're diagnosed with it. And so, if you just get diagnosed with breast cancer today, you think like yesterday you didn't have cancer yesterday, but all of a sudden now you have cancer, right? Well, no, for epithelial cancers, meaning solid cancers, not lymphomas, leukemias, that can happen quicker. But for solid tumors, these epithelial tumors, like the common ones, lung cancer, colorectal cancer, breast cancer, prostate cancer, decades to develop. The breast cancer that a middle-aged woman is diagnosed with started in their teens or even earlier. So you've had breast cancer not for 5 hours, you've had breast cancer for 30 years. You just didn't know it because it wasn't picked up yet. And so all the while you were eating healthy to prevent cancer, well, actually you were treating the cancer that you had. And in fact, when you do those same kind of autopsy studies on young women so you take 30-year-old women, accident victims, and you actually do autopsies, 1 in 5 have breast cancer. 1 in 5 women walking around have breast cancer. Doesn't mean they're going to get breast cancer in their lifetime, because most cancers disappear. We have a whole immune system that just attacks cancer all day long, these natural killer cells and other parts of our immune system. Cancer cells are popping up all the time, and they are being, it's like whack-a-mole. And so every day we are both preventing and treating cancer by our choices, whether we're smoking or not, whether we have radon in our house or not. I mean, it's this constant balance. And so the same diet that prevents is the same diet that treats, because it's slowing the rate of cancer so your body can have a better chance at combating it. So for whatever cancer you have, there may just be a video on nutritionfact.org on preventing that particular cancer, but that would be the same diet you would go on to maximize your chances, even if it's never actually been put to the test.
Very good. How are we doing on time? We've got a few more minutes here. There are 2 questions here that are kind of similar, so I'm going to throw them both out at the same time. Somebody asked, what about probiotics? And then someone else asked, are fermented cruciferous veggies as healthy? So both dealing with probiotics there.
Okay. So probiotics are the only indication, as far as I'm concerned, for probiotics is for the treatment of antibiotic-associated chronic diarrhea. So it's diarrhea for over 2 weeks after an antibiotic course. You're wiping out your good bugs. They'll come back, but you can kind of accelerate that process by taking kind of a mixed acidophilus or bifidobacteria preparation. You can get at the store. Of course, you have to make sure it's alive. It may have been sitting in a truck somewhere. It needs to be refrigerated. And the cold chain has to be intact. So you can actually take it home, pour some, soy milk in 2 bowls, open up a capsule in one of them, wait overnight, and the bowls should look different. One should be bubbly and foamy and filmy, and the other one not. And if they both look the same when you pour them down the drain, then your probiotics is dead. You go back, you demand your money back. But those are really the only indications, because it doesn't matter what kind of bugs you put in your gut. The reason you don't have good bugs in the first place, if that's the case, is because you haven't been feeding them the right foods. And so it really comes down to prebiotics. Prebiotics are what your good gut bugs eat. And prebiotics are predominantly dietary fiber and resistant starch, found predominantly in legumes, beans, split peas, chickpeas, and lentils, as well as whole grains, particularly intact whole grains like whole groats, like oat groats or barley groats. This is what our good gut bugs eat. And so you eat all these probiotics are fiber eating bugs. And so, yeah, you take all these probiotics and then they just die off, right? You're starving your microbial self by not eating enough fiber rich foods. Whereas if you eat the good foods, they don't need any help. They're already down there. They're just starving to death. When you start feeding them, they will be fruitful and multiply. And that's why you can see this, dramatic, doubling of stool weight by eating more fiber. It's not the fiber itself, but more than half of stool is pure bacterial mass. It's just this massive factory of bacteria down there. And they have benefits not only for laxation, but they produce the short chain fatty acids, which are absorbed in your system and have anti-inflammatory effects and appetite suppressant effects, all sorts of good things. And so we feed them and they feed us right back.
Yeah.
Oh, and then in terms of fermented cruciferous vegetables like sauerkraut, kimchi, the problem, salt. How do you prevent the bad bugs from growing when you're fermenting cabbage? You add lots of salt. And then that's obviously a serious problem. And so if you insist on eating sauerkraut, make sure you rinse it to rinse as much of the salt off as well. It's still a high salt food. Yeah, so that's the downside, unfortunately.
Great. If we have time, one last question just popped up here that I think might be beneficial for people if we have time for one more. So this person says she'd like to ask if high protein diets, not plant-based, promote anabolic pathways that will eventually promote cell division and therefore serve as a promoter of tumorigenesis.
Yes, but it depends what kind of protein. So animal proteins and plant proteins are different in that animal proteins tend to have more branched chain amino acids and sulfur containing amino acids. And so have amino acids like more leucine, more methionine, and they're associated with higher mTOR activity and IGF-1 activity, these kind of growth promoting, cancer promoting activities. And so we should try to stick to the 0.8 grams per healthy kilogram of body weight recommendation from the Institute of Medicine for protein and for fear of fueling cancer growth. But most people eat twice as much as the estimated average intake, estimated average requirement. Like we're at like 1.1 grams per kilogram, 1.2, and which is fine as long as we're sticking more towards the plant protein side than the animal protein side.
Well, that concludes our time here, so we can keep on our schedule here. But I just want to thank you so much, Dr. Greger, for joining us. Again, I'm a huge fan, and I really appreciate you taking the time to be with us today and answer our questions. And I see you've been exercising this whole time, and we're actually getting ready to go into a session with Dr. Kathryn Schmitz, who will get us all moving. Everyone will be moving.
Fantastic. So, all right. Well, so happy to be here. Keep up the wonderful work yourself.
Thank you. Thank you very much. Okay, so with that, let's take a short, about 5-minute break, everyone. So you can leave your computers here for a few minutes, and then we'll come back with Dr. Kathryn Schmitz. Okay, I think we've had about 5 minutes here. So to keep us back on track, I'm going to go ahead and get started. Everybody, welcome back from your break. Next, I have the pleasure of introducing you to Dr. Kathryn Schmitz. Dr. Schmitz is a distinguished professor of public health sciences at the Pennsylvania State University's College of Medicine. She is a clinical trialist who has led many exercise trials. Dr. Schmitz has also translated her work into clinical practice and served as president of the American College of Sports Medicine, ACSM. Dr. Schmitz has chaired the Global Exercise is Medicine Governing Committee, and she is the founder of the Moving Through Cancer initiative of the ACSM. Dr. Schmitz has published more than 260 peer-reviewed scientific papers and has had $25 million in funding for her research since 2001. She is the lead author of the first ACSM roundtable on exercise for cancer survivors. In March 2018, Dr. Schmitz co-chaired an international multidisciplinary ACSM roundtable on exercise and cancer prevention and control. The physicians, outpatient rehabilitation specialists, researchers, and exercise professionals in the room broadly agree it is time for exercise oncology to go prime time. The question is how? Dr. Schmitz's professional mission is to answer the question. Dr. Schmitz, welcome.
Thank you very much. I think I get to share my slides now, yeah?
Yes.
Okay, so give me just a moment, everybody. Somebody wants to sing some elevator music, that would be awesome while I figure this out. Okay, so the big question is, what do you all see? Do you see the preparation slides or the presentation?
Yeah, I see the title slide, but I'm so tired. Why cancer patients should exercise anyway.
Okay, do you see any of the sort of stuff around it with the notes and all that? No, awesome. Nope. And you're seeing the presentation, that's good. That's fantastic news. Zoom is a mysterious mistress and we never know quite how it's going to come out. Okay, so hello everyone. Thank you very much for being here today. I am delighted to have an opportunity to exercise my efforts in science communication. I am an exercise oncology researcher, and everything that I'm going to tell you today is based on sound science, very careful and sound science. I have great news, having heard the end of the last talk. What we're going to talk about with exercise is a great deal less complicated than the nutrition story. And so here we go. I'm going to jump right into this presentation and give you an overview. So the first thing we're going to do is we're going to do 3 exercise snacks, because one of the things that I hear from people a lot is, you know, how hard it is to get started with doing some kind of exercise on a regular basis. And so for those of you that are in that situation, I would like to offer to you that, you know, keeping with the nutrition theme, let's try starting with some snacks. So we'll do 3 exercise snacks together during my talk today. I'm going to talk about why you should exercise for cancer prevention in the first part of my talk, and then we'll do a second snack. And then why you should exercise during and after treatment for symptom management. And then we'll do another exercise snack. And then I have a section of my talk that is really intended to be inspiration based on, you know, seeing what the outer limits are. One of the reasons that I include this last section in talks to the general public and to my colleagues is that there is a culture of cancer that if you know, sort of ask the average person on the street to close their eyes and picture a person with cancer, they generally see someone bald, sitting in a big, you know, oversized chair with a blanket over their knees and an IV in their arm. And they don't see someone moving. They don't see someone exercising. This used to be the case for heart disease too. But we changed that culture. We now really understand that exercise is really, really important for a damaged myocardium. We need people who have had a heart attack to get up and move. Well, the same is now true. We know, we have the science that tells us that the same is true for people living with and beyond cancer. And so we need to share some of these inspirational stories of what the outer limits of what's possible is so that you understand that you're not going to hurt yourself by being more physically active during your cancer journey. All right. This is snack number one. I've got my standing desk going here and my wall of intimidation behind me, all of my degrees and things. And I'm going to back up and hopefully you can see me. Hello, little me over here. And I'm going to sit down and stand up 15 times and talk to you about it. So we're going to sit in the chair and stand back up. Everybody, come on, let's do it. Sit down and stand back up. And you don't want to hold on to the chair if you can avoid holding on to the chair. Okay. The other thing is you want to pretend that the seat is hot. So you're just barely touching the seat. I think I'm counting right. But like all trainers, I do a bad job of counting. This is number 8. We're going to do 7 more of these. We're sitting and standing. That's 8 or 9. Sorry, that's 10. We'll do 5 more. Good job. I'm starting to breathe a little bit harder. And 13 and 14 and 15. Excellent job. Good job. Okay, that's snack number 1. And by the time we're done today, you will have done 3 minutes of exercise. That might be 3 minutes more than you've done for a while. So good for you. All right. So now while I'm winded, I'm going to tell you the next bit of information. So this slide is intended to tell you about the evidence base in the field of exercise oncology so that you don't think that it's just me here at Penn State doing a study or two. In fact, the first clinical trials that were done on exercise in living human patients with cancer were done in the late 1980s at Ohio State University. And by 2005, there were 22 clinical trials. By 2010, when we published the first ACSM roundtable, there were nearly 225 randomized controlled trials in the area of exercise oncology. And in the period of time between that first roundtable in 2010 and when we did the second ACSM roundtable in 2018, there was an exponential growth. This is not hyperbole. There was an exponential growth in the amount of randomized controlled trials in the area of exercise and cancer, so that we now, at this point in 2021, have well over 1,000 published randomized controlled trials demonstrating the efficacy of exercise for people living with and beyond cancer. As a result of that exponential growth, there was a decision made by the American College of Sports Medicine to hold an international multidisciplinary roundtable on exercise and cancer prevention and control. And as you can see, I was really honored to get to be one of the co-chairs, along with my colleague, Chuck Matthews from the National Cancer Institute. You can also see that we had a number of partner organizations in the room. One of our goals in having this conversation, this 2-day meeting, was to bring everybody into the room and into the conversation that would have a say in the matter in making exercise standard of care. So we had medical oncologists, we had surgical oncologists, we had family practice docs, we had nurses, we had physical therapists, we had PM&R doctors, and we also had 5 representatives from other countries that came and joined us as well. So the first section that I'm going to talk to you about is what we reviewed at that meeting that was specific to exercise and cancer prevention. So when we look at the potential for exercise to prevent cancer, we obviously are interested in understanding the mechanisms through which that might occur. And so we know that there are a number of biological mechanisms that exercise has strong effect on, that also have a strong effect on cancer biology. They include body fat, and as a result of changes in body fat, sex hormones, insulin sensitivity, and chronic inflammation. There are a number of other mechanisms that are, some of them modifiable, some of them not, age being one that's not. We can measure a variety of different kinds of biomarkers that help us to understand whether exercise has had an effect on any of those particular pathways, including insulin, IGF-1, C-reactive protein, gene expression, and a number of others. But we also can do this work in a variety of different patient populations. And so we can do observational studies where we look at people who are more versus less physically active and focus specifically on ER positive patients or ER negative patients, HER2 positive patients or negative, and then a variety of different subsets and possibilities for a lot of different other cancers, including colon. So we can then conclude on the basis of that information that exercise would be protective or would not be protective. And so this is the kind of research that happens in the area of cancer prevention and exercise oncology. So there are 3 different types of studies that we would do in order to be able to draw any conclusions. And I think it's important, if you are reviewing evidence and you're deciding whether or not in reviewing what you hear in the media or read in a book is true, is backed by solid evidence, you need to understand the types of studies that have been done in order to draw the conclusions that are being drawn. Observational studies are one of the types of studies that might be done. Exercise randomized controlled trials, which I told you there's been over 1,000 at this point, can also be done. And there can also be molecular epidemiologic studies, which are also observational, but are different than the observational studies meant in number 1 there. So when we say observational studies, what are we talking about here? Well, first thing to know is that there have now been literally hundreds of studies that have been done over the course of from the 1990s to the most recent review took us through the 2017. There have been more since then, but this is sort of, looking at what has been published in review at this point. There are a variety of different ways of doing observational studies, and the particular way that this author, Christine Friedenreich, who is the queen of doing this kind of review, what she focuses on are prospective cohort studies, which means that we gather a group of people together, we measure them, and then we follow them over time to see what happens. The length of follow-up for individuals in these studies has been anywhere from 6 months to 10 years. And you can see that the number of cancer cases in these cohorts has ranged from anywhere from 242 to nearly 300,000. So these are exceptionally large studies, some of them pooling projects with individuals across multiple countries in Europe or across North America. You can see that there's a broad variety of the number of deaths that are included in these studies as well, and cancer-specific deaths, as well as recurrences and progression. In terms of the years in follow-up, 2 to 20 years, very, very broad range there. So the idea here is that I'm trying to give you an idea of the scope of the kind of science that happens here. This would be an example of this kind of research would be the Nurses' Health Study. So in the Nurses' Health Study, they have gathered hundreds of thousands of nurses who are willing to fill out surveys on a regular basis, are willing to give blood samples and to do other types of biometric studies. And then they follow them over time. And by virtue of asking them about their physical activity level and then following them over time, they're able to tell us with more precision than you might imagine exactly what particular amount of exercise was associated with prevention of breast cancer. And indeed, it was the Nurses' Health Study that heralded a brand new era of understanding of the role of exercise in preventing secondary prevention of breast cancer in particular. So the other thing to understand is that with this kind of prevention research, we're not going to be doing laboratory-based testing of the fitness level of each person. Instead, we're going to be doing physical activity assessment, all of it self-reported, mostly focused on recreational activity. That's important because there could be people who are FedEx drivers and are carrying boxes all day. And so there's an important potential confounder in all of this work. Usually the physical activity is assessed before people start any kind of treatment or a diagnosis even. The number of assessments varies. The number of other periods of time that they control for varies. Controlling for sedentary behavior is done in some of the studies, but not all of them. And generally speaking, the physical activity is reported in this interesting metric called Met hours per week, which is an attempt on the part of the researchers to try to explain to you the time, the intensity, the duration, and the frequency with which the person is physically active in one number, combining all of that information in one number. So here's what we know about physical activity and primary prevention. So first, I'm just going to focus on breast cancer, just to give you an example, and then I'm going to show you an infographic, which includes the 7 major cancers for which we believe we have substantive evidence of a preventive effect. So in the setting of primary prevention of breast cancer, there have been 28 large observational studies, prospective cohort studies that have studied whether or not being more physically active prevents premenopausal breast cancer. And the answer is yes. And the magnitude of the decrease is 18%, which is not to be sneezed at. That's a fair bit of risk reduction. Very similar risk reduction in postmenopausal women, with 35 studies having been completed. So that's for that particular cancer, for that one cancer. But what we were able to conclude on the basis of a large review of the literature that was done because of that roundtable that I mentioned to you, the person who led this particular review was Alpa Patel, who is the lead epidemiologist at the American Cancer Society. And Dr. Patel led an expert team that came together and looked at all of the reviews and all of the evidence to date as of 2018. And what they concluded was that exercise does prevent breast cancer, endometrial cancer, kidney cancer, bladder cancer, esophageal cancer, stomach cancer, and colon cancer. I want you to note that prostate cancer is not on this list. For primary prevention, we do not have evidence that exercise prevents prostate cancer. Keep that in your mind for just a second as we move forward. And now I want to talk to you about physical activity and cancer survival. The review that has been done in this area is equally robust. And rather than go through all of the quality of the evidence that I tried to sort of point to in my prior slides, I'm going to ask you to go with me to say that it's very similar to the evidence base for primary prevention. And when we summarize the state of the evidence for physical activity and cancer survival for all major sites, what we find is a substantive 40 to 50% reduction in cancer-specific and all-cause mortality for more physically active people who have had breast cancer and colorectal cancer, as well as, interestingly, prostate cancer. So no primary prevention effect with prostate, but a secondary prevention effect for prostate. Interestingly, we do not have sufficient evidence for the rest of the cancer sites that are listed on this slide. That does not mean that exercise is not useful for prevention of recurrence or for survival for those disease sites. It means that we don't have enough studies. And one of the sort of obvious reasons for that is that these are, in particular for kidney, endometrium, and ovarian, less common cancers. And so we just simply have less people in those studies that have had those diseases that we can follow over time. So all of the data seems to be pointing us in the direction of that we will eventually see more cancer sites for whom we believe that there is a survival benefit of being more physically active. All right, we're going to do an exercise snack before we switch to talking about exercise during cancer treatment. Now, this one is shown seated, but I don't think you'll see me if I back up. So we're going to do calf raises. I'm going to do them standing. You can sit in your seat and raise your heels if you'd like. And I'm going to do 15 of these. That's 3. I'm at 3. And here we go, number 4. Did you know that your calves are the most important muscle that you need in order to go up and down the stairs besides your thighs? and that one of the reasons why older adults stop being able to go up and down stairs and lose that ability is because of loss of strength in their calf muscles. You aware of that? So your calf muscles are extremely important. And if you've been through a cancer diagnosis and treatment, then it's very likely that you've lost some strength in your calves. And so calf raises are an outstanding exercise. And there's something you can do while you're holding on to something. I'm holding on. While you're holding on to something, while you're in the grocery line. So no excuses not to do your calf raises. Okay, I think I got to 15 there. So I'm going to move on to the next slide. So now I'm going to switch topics now to talk about other cancer health-related outcomes. We do recognize that prevention of cancer and prevention of recurrence of cancer is going to be of utmost importance. But if you are someone who has had a diagnosis, then you might really be interested in knowing whether exercise has any particular effect on symptoms, treatment tolerance, adverse effects of treatment. And so there was a second paper that came out of that ACSM roundtable that occurred in 2018. And one of the goals behind this particular paper was to examine the FIT principle, which is frequency, intensity, time, and type. And our real interest here was to understand exercise like a medicine. So we don't tell people to go get some chemotherapy, right? We tell people to go get some exercise, non-specific, but we don't tell them to just go get some radiation or go get some chemotherapy. We're very specific. We say, I'm going to give you doxorubicin. I'm going to give you this particular dosage every 3 weeks. Here's how fast the drip is going to go. This is, how you're going to recover. There's a lot of specificity to a medicine. What we wanted to know was, is there randomized controlled trial evidence that we could use to develop a fit prescription very specifically for very specific outcomes that are of interest to patients and doctors as patients go through their treatment and recover from their treatment. So we had to have some rubric, some way of deciding yes or no. Is there enough evidence? Is there not enough evidence? And so this was the decision tree that we used. We borrowed this from the Dutch physical activity guidelines that just happened to have been completed right before we started this process. And going from the left to the right side of the slide, what I want to point out to you is that we only used randomized controlled trial evidence in this particular part of the review. So this was not observational evidence. This was the highest quality of science you can get, randomized controlled trials. And if we did not have 5 trials for a particular outcome, say cardiotoxicity or lymphedema or fatigue, then we said, nope, there wasn't enough evidence. But if there was at least 5 trials with at least 150 people in those trials, then we looked at whether or not the effect was close to zero or not close to zero. In other words, was there something to say? Was it, did the exercise do something? If it did, then we looked at whether or not the effects were consistent across the different trials. That's about the heterogeneity in effect. That's what we're looking at there. Based on this, decision pathway, we come to the right side of the slide and we either decide that there's green and we can make a fit prescription for a particular outcome, yellow, and we decided that we could do a fit prescription for the yellow as well, or a red, which was, nope, we don't think that there is enough evidence for us to draw the conclusion that we can prescribe exercise precisely like medicine for that particular outcome. Now, what outcomes do we look at? This crazy bunch of scientists came together to review 16 major outcomes that are related to what happens to people as they're going through their cancer treatment and recovering from their treatment. We found that there was strong evidence, a green fit prescription for 6 different outcomes: anxiety, depressive symptoms, fatigue, health-related quality of life, lymphedema, and physical function, with physical function being defined as your ability to do the things that you need to do, like walk up and down stairs, go get your groceries, carry something in and out, care for children, lift the things that you lift in your life, go for a hike, whatever it is that you need to do physically in order to function in your life. We found moderate evidence for a fit prescription for 2 outcomes, bone health and sleep. And we found insufficient evidence for 8 different outcomes, and those are ones that are under study right now by exercise oncology researchers. So I'm going to show you the information underpinning the fit prescription that we made for 2 of these 8 outcomes. I'm not going to, give you the deep details. My point in showing you this is to show you that it's not just that somebody did a study with 10 people and we are saying, yeah, there's an effect here. There's a lot of evidence behind this. And these are real problems that real people are experiencing that exercise can help with. So cancer-related fatigue is the area for which we have the largest evidence base. It is highly prevalent during chemotherapy. 90 to 100% of patients report significant cancer-related fatigue. There are over 200 randomized controlled trials that have been done in the area of exercise and cancer-related fatigue. It is, as I said, the largest area of evidence in exercise oncology. There have been multiple large review papers that have been written about this evidence base. The evidence base is available for a variety of different cancer entities, treatment types, timing within treatment, exercise approaches, and overall the effect sizes come in at what's called a moderate level of effect, which is like saying a drug that has a moderate level of effect. So it's not like, I could take it or leave it, the drug doesn't do anything. This is something that actually has a meaningful effect. The other thing that we have noted and has been looked at is that patients with higher levels of fatigue benefit the most. Now, that's a little crazy making, right? Because, I can just hear somebody saying to me, okay, so what part of I'm fatigued do you not get? When I ask them to get up and go for a walk. But I can absolutely guarantee somebody who is experiencing debilitating fatigue that if they will get off the couch and move for a few minutes, they are going to feel better than if they continue to sit on that couch. The effects that we see in exercise and cancer-related fatigue are not influenced by any of the things listed in sort of the rainbow on the left side here. Cancer type, presence of metastasis, treatment status, delivery mode, delivery setting, type of exercise, duration, or other methodological parameters. And in what I think is one of the most important papers that's been published in the area of exercise oncology, Protean, friend and colleague of mine at University of Rochester, did a head-to-head comparison between pharmacologic interventions for cancer-related fatigue as compared to exercise or exercise plus psychological interventions. And what I will draw your attention to is that I'm going to talk you through here that on the left side of the column in the table, it says all of the different types of interventions. The next column is the number of effect sizes, which is like saying the number of studies. The next column says WES, that is the weighted effect size. And then there's the standard error and the 95% confidence interval. And so for exercise, we see a weighted effect size of 0.3, which is a moderate effect size. What I will then point out to you is that under the red, or just above the red line, you can see that there were 14 studies that used drugs to try to address cancer-related fatigue. And I'll point out to you that the weighted effect size is 0.09, and that it is not, that the 0.09 is not considered statistically different than 0, which is to say there is not a drug on the market that is likely better than exercise for cancer-related fatigue. So to sum up in the area of exercise and cancer-related fatigue, the fit prescription during cancer treatment is to do 3 times a week aerobic exercise, 30 minutes per session, and twice weekly strength resistance exercise with 6 to 8 different exercises. So it could be your calf raises, and then the chair stands that we did, and 4 more. You want to do each exercise 2 times and increase the resistance by a very small amount every few sessions. And increasing resistance does not have to mean that you have to go out and buy something expensive. You could use water bottles and fill them with a variety of different amounts of water within the water bottle and hold the bottle, or put it in a plastic bag and hold out of the plastic bag. And that is a quick way to get your resistance. Okay, so the other outcome that I'm going to talk through is lymphedema, and this is very specific to breast cancer-related lymphedema. And the trials that were included, because there were only 5, I can show you that there were 5 here, and 3 of these were mine. Ahmed was my doctoral student. So Ahmed, I was last author on that, and 2 others are mine as well. The largest of these trials was the PAL trial, which was a National Cancer Institute sponsored investigator-initiated trial. And the goal of the PAL trial was a 1-year randomized controlled trial of twice-weekly progressive strength training compared to a non-exercising control, with a primary outcome to determine whether there were any changes in lymphedema outcomes. And very importantly, this grant was funded as 2 separate trials. So we started with a group of women that already had lymphedema and a separate group of women who were at risk for lymphedema at the beginning of the trial, and we randomized them within lymphedema status at the beginning. These trials were powered independently. The results for the women with lymphedema were published in New England Journal of Medicine in 2009, and the results for the women at risk for lymphedema were published in JAMA in 2010, so well over a decade ago now. And the summary of what we found from the PAL trial was that twice-weekly, slowly progressive strength training is safe for breast cancer survivors who've had lymph node removal, including those with and at risk for lymphedema. The risk of lymphedema flare-ups was cut by half, which begs the question of whether this might be a cost-effective intervention. Among women at risk for lymphedema who had had more than 5 nodes removed, the risk of increased arm swelling was reduced by 70%. So in essence, we prevented onset of lymphedema in women who were at elevated risk because they had had more nodes removed. We also showed substantive strength improvements and improvements in body image, appendicular skeletal muscle mass, and we prevented decline in functional status just simply with twice-weekly, slowly progressive strength training. So to sum up the evidence base from PAL, but also from all of the other trials, there is a finding of safety specifically for resistance training. All of the trials that have been done in the area of exercise and breast cancer-related lymphedema ask that women start with supervision and started with a start low, progress slow kind of mindset. I have done preliminary studies and can say that the preliminary data for lower lymphedema does not support assuming that the results of these trials in breast cancer-related lymphedema would translate. There is currently no evidence that is specific to the safety and efficacy of aerobic exercise training with regard to breast cancer-related lymphedema, but there have been so many thousands of women that have been in trials that have or are at risk for breast cancer-related lymphedema, and there have been no reports of adverse events. So there is a presumption of safety. All right, so there are 6 more outcomes. I'm not going to go through the evidence base for each of those. I wanted you to have a sense that this is a group that really took very carefully, all of the information from the science and rigorously reviewed in order to make fit prescriptions. And so we have developed an infographic that will help you to know what the fit prescription is for the 8 cancer health related outcomes that we believe exercise has a positive effect for. This infographic is available at the website that I'm pointing to on this slide. In addition, there's a lot of information here, and I'm really, really aware of the fact that there is a need to translate this scientific evidence base into for the lay audience. And so I've written a book that is, in essence, a translation of this entire evidence base and shares my own family's cancer story. And this book is available for pre-sale at this point and will be released on October 19th. If you are interested in this, there is something out there that is kind of the Peloton for cancer survivors. It's called My Victory. And if you purchase the book and go to my website, you can get a year free membership at My Victory if you're interested. So you would go to the accompanying website and sign up for that. that's of interest. All right, exercise snack number 3. This is seated jumping jacks. Okay, so I'm going to go back here again, and I'm going to sit down, and we're going to do jumping jacks. So hopefully you can still see me over here. And what you can see then is that the person on the screen is jumping out and then coming back together, jumping out, coming back together. We're going to do 15 of these. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay, you can keep going while I keep talking if you want. Okay, so now I want to talk to you about what's possible. This is exercise oncology in action. And the first story I'm going to share is from my friend Bill Jolly. Bill Jolly goes by Jolly, and he is. And in spring of 2011, about 10 years ago, he was about 15 years out from being in the Marine Corps, and a friend invited him to train for a sprint triathlon. And, in June, he was like, oh man, wow, I'm out of shape, but should I be this tired? And in the summer, he developed chest congestion, nothing on the chest scan. They thought it was adult onset asthma. By August, he sounded like he'd swallowed a whistle while he was running. In September, the PCP ordered a second chest scan and said, well, it looks like you have an enlarged heart. It's probably nothing. But, I'm gonna have my friend, the radiologist, take a look at this. The radiologist recommended a CT, and they diagnosed stage 3 lymphoma. Biopsy revealed that it was small lymphocytic lymphoma. And in January of the following year, he started 6 cycles of chemotherapy. And I won't tell you where he was treated, but I can tell you that he went to his comprehensive cancer center and said, where's the exercise program? And they said, exercise is not ubiquitous at cancer centers, and patients need to demand it in order for it to start to be something that's a normal part of cancer treatment. So he was told to call up the leukemia lymphoma team and training folks, and he started training with them the same month that he started chemotherapy. And to make a long story short, he did really well. 5 months after chemo, he did his first marathon, and then an Olympic tri the following year, an Olympic tri the year after that, a half marathon 4 years later. And unfortunately, Jolly's cancer relapsed in 2016, and he started oral targeted therapy. And in January of the following year, he was saying, I don't feel like myself. I don't want to work. I don't want to talk to my wife and kids. I don't want to do anything. So one day, 10:30 at night, he was like, I got to go out for a run. And he said 1 mile into the run, the fatigue and depression vanished. And he finds that if he exercises every other day, that he's able to manage his anxiety and depression. And he completed a full Ironman in fall of 2017. And so this is his ideal training plan. That's a lot of exercise. And I love the caveat at the bottom where he says, well, I've got this, 3 girls, and I've got a new foster child and a busy career. Sometimes he doesn't get them all in, but this is an awful lot of exercise for somebody who is undergoing oral therapy. So my point in sharing this with you is to share Jolly's takeaways. And the takeaways, rather than reading this bullet point, I think that there's really sort of a secret sauce here. And this is very much, part of the book that I've written as well. If you are exercising on a regular basis, then you know what's going on with your engine, with your body. It's the same thing with your car. If you don't drive your car and then your car makes a noise, you don't know if it's a new noise, right? It's only by driving the car on a regular basis that you get to know the sounds in the car and how it drives and whether anything's different. Same thing with your body. Your body is your instrument for life, right? So if you use the instrument on a regular basis, then you come to understand what aches and pains are sort of a normal, oh, yeah, there's that, that happens all the time, versus that's new, right? That's new, that's different. And so if you are exercising on a regular basis, you are better able to tell your clinicians what is happening with you, and they are better able to know whether or not there's something amiss, and better able to help you with whatever might be amiss. Okay, so rather than read those bullet points, I'll share that. I love his last bullet point. Exercise gives patients control of their lives back. It gives you something to focus on other than the fact that you have cancer. I'll just say one more thing about that, and that is that even in someone with metastatic cancer, you have more healthy cells in your body, trillions of them, in fact, than you do cancer cells. Those healthy cells are working diligently to try to help you to stay healthy, and they deserve a little attention. Okay, case study number 2. Norma was at age 61 and had metastatic breast cancer when she came to work with us at Penn State. She had a number of other chronic conditions at the same time. When she enrolled in one of our studies, she walked with a walker. She had to take frequent breaks, even with the walker, to sit down due to weakness in her legs. She had had a spinal surgery because of compression fractures in her back, and was told she would mostly be bedridden for the rest of her life. We prescribed for her a tablet-based supportive care intervention that we have been working on for the past 4 years, called Nurse Amy, addressing malignancies in individuals every day. And in this, we basically ask, what are your daily symptoms? We provide a daily intervention, and we talk to people weekly. This is what the intervention looks like. So we start with a daily reminder, and the nurse says hello. We ask symptoms and ask them for their step counts. The nurse has an empathic response that basically says, oh, I'm so sorry your symptoms are bad, or hey, that's great, it seems like you're doing great. And then there are guideline-based intervention modules that we use, and we share the information with the clinicians so that the clinicians can decide whether the patients should continue with the self-care for their symptoms, or whether something new has happened that they should, shift gears so that they can manage medically. At the end of our study, she was averaging 10,000 steps a day and ambulating on her own. She didn't need assistance, but she carried a cane just because, just for, making sure that she felt safe. She strutted in at the end of the study, swinging her cane in circles like a Charlie Chaplin, to show how well she could walk. And we were very, very pleased for Norma and how well things went. The list goes on. Sydney Hooper is a 7-year pancreatic cancer survivor and Ironman competitor. Susan Helmerich is a 3-time survivor, DES daughter, also lung and pancreatic cancer and master swimmer in San Francisco. Gabriella Grunwald was an adenoid cystic carcinoma patient diagnosed a decade ago and placed 4th in the 1500 meter in the London Olympic trials while she had cancer. She was the national champion in the 3000 meter while she had cancer. She had a quote over her couch that said, if there are 2 ways to live your life, the first is as if nothing is a miracle, and the other is as if everything is a miracle. And clearly she followed the second. Mike Levine, similarly, stage 4 pancreatic cancer Ironman competitor. And Keegan Randall. Keegan Randall is an American US Olympian gold medalist in cross-country skiing, who was already a phenom in Pyeongchang when she won a gold medal. Very rare for gold medals to happen for the US in cross-country skiing. And she had a baby. She was a young mom at the time. And she came home 3 months later. She was diagnosed with a stage 3 cancer. And, she went through cancer treatments and, had bad days like everybody. And, there's a whole chapter in my book about these athletes and how they do and what's possible. So based on these stories, what I would say is that it is time for these examples to stop being exceptional. It's time to recognize that, if you have one person that's out there that's able to do these kinds of feats during their cancer treatment, then you might think, wow, that's a really unusual person. But if I can list all of these and I'm not listing more because I'm running out of time, then clearly it is possible to do more during cancer treatment than we previously thought. We're not going to hurt patients by having them be more physically active. It is time for a paradigm shift. Exercise is medicine for people living with and beyond cancer. And so I'll commend the Moving Through Cancer initiative to you. And thank you very much for your time. And I look forward to your questions.
Thank you so much, Dr. Schmitz. There was a comment while you were speaking that this was a spectacular presentation. So I'll just throw that out there. With the ending of your presentation, how far do you think we are away from that paradigm shift happening? We exist, Karuna Precision Wellness Center exists because so many people experience that, kind of getting shoved off of a cliff after traditional treatment for cancer has finished. How far away do you think we are from there being oncology rehab, just as there is rehab for a cardiac event?
That's a really excellent question. Right now, people, are lucky to live close to you all. Interestingly, it's, really, it's fantastic to live in Tyler, Texas. There are 2 major cancer exercise programs that exist in Tyler, Texas, just as an oddball example. And then there are other places that are kind of exercise oncology deserts, if you will. And what's fascinating is how you can find those exercise oncology deserts in places where there are major cancer centers, and there's not a program for anybody. So I think that there are a number of initiatives underway to try to shift this. Some of them commercial, some of them are more homespun. The Moving Through Cancer initiative has an agenda that is, very much about trying to change policy and to see if we can get, do it the way that they got the diabetes prevention program covered by third-party payers was through demonstration projects. And so we have designs on doing demonstration projects for exercise oncology as well.
Thank you. Okay, I'm going to go. The first question that came in, and I believe it was asked early on in your presentation when it refers to studies. So the question is, are those studies on exercise preventing cancer and improving survival odds, do they control for obesity? That is, if you have the same BMI but exercise more, are your risks improved by something other than being or becoming less overweight? Basically, this is a question of mechanism of the exercise benefits.
Yes. And I debated, like, do I put this slide in? Do I not put that slide in? And apparently I should have. But yes, the answer is yes. There is an effect of exercise on obesity that does make a difference. That is an important aspect of the role of exercise. But if we take, pool the studies and, have hundreds of thousands of cancer cases and millions of people that have been followed, and we control for BMI, which is our way of measuring obesity, we still see an effect of being more physically active in cancer prevention for those 7 outcomes that I noted before.
Great. Okay, so we have about 10 more minutes for questions. So next question, is there any data on cancer of the pancreas and exercise?
Just starting. So I have a pilot that I've done at Penn State. There is a pilot that has been done at MD Anderson. I would say that we are at the baby beginnings of trying to understand pancreatic cancer. One of the things that I think has happened in the field of exercise oncology is that we have been the vanguard to notice that it is possible to exercise people who were previously off limits, if you will. So when I started my career, the idea of doing a study that included metastatic patients was unthinkable, just unthinkable. And now it's like, actually they're able to exercise. And so a similar thing happened with pancreatic cancer because it's such a serious diagnosis. I would say that the evidence is preliminary and promising. That's
Okay.
about as far as I'm very, like I am not going to tell you something if I can't really nail it down with the science.
Fair enough. Well, and that's what is so great. I mean, there's so much conflicting information out there. And again, most patients, I think, look to their oncologist for this information, and a lot of them don't have it. So that leaves us as survivors, kind of flailing out here. And that's what I love about your presentation today, is that you, and Dr. Gregor's as well, that you guys provide the scientific evidence to back up what you're saying, which is so important when you're out here trying to figure this stuff out on your own as a survivor or going through cancer. Okay, so another question here is the reason for exercise reducing breast cancer risk due to reduced estrogen production?
Could be part of it. And certainly that's something that we'll continue to look at. But there's also evidence that there is an effect on inflammation and in breast tissue. And there is also evidence of an effect on the insulin pathway. So the way that the body processes insulin changes as a result of being more physically active in a pretty dramatic fashion. And interestingly, not just because you've exercised for 10 years, it's actually an effect that happens acutely. So it's something that happens in the day after you exercise, and then happens again the next time you exercise. And so there is a long-term effect is only there if you keep doing it, if that makes any sense. So there are a number of mechanisms that are under study right now. I'm actually writing another grant in that area. So we're hoping to do a large randomized controlled trial to look at breast tissue and to understand what's happening in the insulin pathway, as well as to estradiol. And we're doing imaging as well to see if the breast tissue that lights up because it is hormonally sensitive, whether or not that changes in women with dense breasts. So stay tuned there.
Very good. Here we have it's more of a comment. At least 7 Asian countries apply integrative therapies as a norm alongside traditional treatment. The US and Canada are behind.
Yeah, I saw this one. Yeah, agree. Yeah. And we tend to be, I'm the chief scientific officer for an organization called Maple Tree Cancer Alliance that is trying to bring exercise oncology to hospitals across the country and internationally. And we have just been astounded at how quickly our colleagues in China are just like, let's go, let's make this happen, and in South America, same thing. So, meanwhile, we healthcare is still very much a for-profit model in the US. And as a result, there's not a whole lot of profit unless you are in a healthcare market that is exceedingly competitive. If you happen to be in a healthcare market that's competitive, then it's possible to get one of the cancer centers to agree to give exercise classes or to have an exercise program because they want to differentiate themselves from the other.
Right. Okay, another comment. I loved your presentation and all of these today. So excellent. I love the idea, quote, we're not going to hurt cancer patients with exercise. I might just add, especially if their phytonutrient protection can keep up with their level of oxidative stress.
Well, exercise actually improves oxidative stress. So we have, I have randomized controlled trials that I've published, but there are a number of trials that show that redox balance actually is improved with aerobic exercise. And so, yes, let's do some phytonutrients as well, but let's do that in concert with an exercise program, an aerobic exercise program, in order to boost F2 isoprostanes, which are a product of arachidonic acid.
Do you have any thoughts on neuropathy and exercise? Is that such a common complaint?
Yes. So this was one of those, scientists sitting in a room will, grind their teeth and wonder, is it time for us to say this or not? And we really pissed off the neuropathy researchers by saying that we're not ready for prime time, because they felt like they were. And so there is exceedingly promising research that being more physically active is helpful for chemotherapy-induced peripheral neuropathy. But it's a catch-22 like the fatigue, because if your feet hurt and it hurts to move, then it's hard to get people to go. The other thing that we have to really bear in mind is safety. And so if somebody is experiencing chemotherapy-induced peripheral neuropathy, then in their hands, then they need, if they're going to be holding on to something for weights, they need to hold on to it in a way that, I'll actually show you, if I can show you what I mean by the plastic bag. So this isn't plastic, it's a cloth bag, but the way that you would do this and make sure that you're okay is, I don't know if you can see, I've got this, I twist it and then I hold on to it, okay? And once I've done that, I can use that as a weight, okay? So I can use any kind of tote bag as a way of getting around needing to have weights in my house. I just put more stuff in the tote bag and then I've got resistance, okay? Plus, by virtue of putting this around my wrist and twisting it, I take it out of my hand. And what's nice about that is if you have peripheral neuropathy, you just may not be able to, it makes me nervous, people dropping things on their feet. If you have peripheral neuropathy in your feet, then you are a balance risk potentially. And so finding types of exercise to do, I have 3 different chair exercise protocols on my website, and you can YouTube for chair exercise things too. So it's not just my website, but I know the ones I have are worthy of you looking at. But I have to say, we decided to do some chair exercise, and I was like, man, chair exercise, it's going to be really easy. No, it turns out you get nice and sweaty doing chair exercise. And so don't, sort of discard it as being less than what you, used to do or whatever. You can actually get a fairly good workout sitting in the chair. So I'm a big fan of enabling people to be active right here, right now, so that you don't need to go out and buy anything. You don't need to go sign up for anything. Let's get you going right now.
Well, thank you so much for your presentation. It's been an honor to have you here, and I look forward to the release of your book and getting that and reading it as well next month.
Thank you. Thank you so much for the opportunity to present.
Yeah, thank you. Okay, so this is a reminder that we'll have a 5-minute break here. We're right on time. It's about 1 minute early, but so we will convene back at 1:50. So we'll give you about 6 minutes for a short break, and then we'll be back with Paul George. Welcome back, everybody. Hope you had a good break. And I'd like to take this opportunity to welcome any new attendees and quickly reintroduce myself. My name is Julia Holbrook, and I am the Executive Director of Karuna Precision Wellness Center, a new nonprofit in Indianapolis, Indiana, founded by Dr. Jamie Renbarger, providing lifestyle and complementary therapies to cancer patients and survivors. Today's symposium is hosted by both Karuna Precision Wellness Center and LifeOmic. Our next speaker is Paul George, a psychotherapist specializing in the treatment of trauma. He is an EMDRIA certified EMDR, which stands for Eye Movement Desensitization and Reprocessing Therapist, and an EMDRIA approved consultant in EMDR. He learned much of what he knows and uses now in private practice from 17 years of experience in community mental health centers in Indianapolis. In these medical settings, he evaluated people in crisis coming to clinics, but also evaluated and did brief treatment with patients in emergency rooms and on medical wards at 2 hospitals in Indianapolis. He has worked for 10 years on an outpatient addictions team at one of these facilities. And through the experience of his clients, medical patients, and his own medical experience, he has come to understand that there are a variety of ways that we can be traumatized, diminished, and even shamed by medical institutions and medical providers, particularly when we are struggling with chronic pain and very serious and chronic health conditions. Please welcome Paul George.
Thank you, Julia. So let me start. Share screen. Well, I'm having trouble finding my Candace. Can you go to there we go. So we're going to talk about medical trauma and PTSD, the impact on patients' emotional health. Next slide. So there are different types of trauma. Single event trauma, things like a bad automobile accident. I've treated people who've been bitten severely by dogs, and people have been mugged at a bank machine. That's a single event trauma. And usually we can clear that with the EMDR process, in 3 to 5 sessions. But there's also such a thing as repeated or chronic trauma. That's multiple similar events over a period of time that have a lot of thematic similarity. Complex trauma is multiple and varied kinds of trauma over a significant period of time. Growing up in an alcoholic family system or an extremely dysfunctional one can create that kind of trauma. Medical trauma could result from any one of these 3 types. Next screen. So what are the symptoms of trauma? Now, these things all can be symptoms of other things, but all of them are symptoms of trauma, and so you might just in your mind check off anything that you identify with. Any reminders that bring back feelings about the original event. Trouble falling asleep or staying asleep. Seemingly unrelated things that you experience make you think about the trauma. Irritability and anger. Trying not to feel upset when you're reminded of the trauma. Feeling like it didn't happen or wasn't real, particularly soon after the trauma happens. Next slide. So, for further symptoms, pictures of the trauma pop up in your mind and are uninvited. Other things can pop up too. That could be a body sense or a sound. And sometimes all these things pop up together, all the sensory information from the experience, and sometimes just one pops up. Feeling numb about the event. That's maybe more common in the beginning, but can extend into long-term chronic trauma. feeling or acting like you've gone back in time to when the trauma happens. I mentioned trouble falling asleep, extremely strong ways of feeling about the event, difficulty concentrating. Next slide. When triggered into the memory of trauma, you can also have physical reactions such as sweating, trouble breathing, nausea, or feeling your heart pounding, and these are all anxiety symptoms. When somebody comes into my office and tells me they have anxiety, one of the things I'm going to do reliably is check for a trauma history, because sometimes these symptoms aren't really an anxiety disorder, they're just the result of trauma. Bad dreams or nightmares about the event, sometimes just bad dreams and nightmares that you don't normally have after the event, can be trauma related. Feeling vigilant or guarded when nothing is happening that suggests that there's a need to be vigilant and guarded. Anger that comes in blaming yourself for something that really probably wasn't your fault or responsibility, or blaming others can be a part of this. Next slide. So trauma is a neurological problem that creates emotional problems. And part of the reason why this is so important is if we have symptoms of trauma, very often we can feel ashamed. We can feel ashamed of the fact that somehow we didn't handle it. We can't deal with it. If we have people that are saying things like that to us, it makes it all the worse, because we may be having those thoughts in our own mind. And then whatever somebody else says is like piling on. So the symptoms in the beginning, the first month after a trauma occurs, we don't label PTSD. We call it an acute stress reaction. If they persist longer than that, then we call it post-traumatic stress disorder. So in PTSD, the communication between our thinking mind and our emotional mind gets disrupted and does not get reestablished well. We're then stuck with the unpredictable emotional responses to the original event when we're triggered, often as it just happened or is happening right now. Next slide. Yeah. So what happens to the brain when we're traumatized? So what we would refer to as the emotional brain is part of a big system called the limbic system. And it includes the amygdala, which most people have heard of, the hypothalamus, the thalamus, and hippocampus. And sometimes it's referred to as the lizard brain. And the reason why is that lizards have this part of the brain, but they don't have a well-developed prefrontal cortex and some other things. That part of the brain which helps us think through things, helps us manage our own feelings, helps us think and feel to work through problems, that process that gets disrupted. Next slide. So, traumatic events activate the limbic system to a degree that can overwhelm the prefrontal cortex's ability to think and feel our way through the resolution of a traumatic event. This leaves the limbic system activated in a way that is consistent with fight-flight or freeze-faint responses. And those are the responses that permitted us to survive as a species. They protected us, and they're still designed to work that way. Jill Bolte Taylor, who was a neuroscientist at Harvard and suffered a massive left hemispheric stroke and recovered from it amazingly, talks about this. The amygdala gets a piece of sensory information and it stamps it. Safe, unsafe, not sure. So before we ever really begin to think about any sensory input we have, whether it's remembered or current, our emotional brain's responding, and it responds very fast, a tiny fraction of a second. But our thinking brain responds in a fraction of a second, but it's a lot longer one. And so there's a way we're always playing catch up somehow to our feelings. And when we are traumatized, this process may get a lot longer between when the thinking brain can kick in and how well it can kick in. So, in the absence of a present threat, The activation by a trigger into trauma produces responses that we often label as anxiety or panic. Our minds and our bodies are responding as if a past threatening event is happening right now, when it is not engendering a sense, which will engender a sense, that we may feel like we're losing our minds, when this is really not so. And so this is a picture of that limbic system. And you can see all the structures in that. The hippocampus is an important structure because it's one that converts short-term learning into long-term learning. And when things aren't working well in the limbic system, we have trouble learning new things. Next slide. And that's a picture of the amygdala, a fairly large structure compared to the others. And that's a picture of the prefrontal cortex, that part of the brain that makes discernments, that makes decisions, that says, I want to do this thing, but I don't think it's probably a very good idea. It could hurt me or other people. Next slide. So the vagus nerve has something to do with all this. The vagus nerve comes out of the medulla oblongata, which is the structure at the base of the brain that regulates heart rate and breathing. And it innervates structures from all the way down from the head into every organ of the body. And so it's an important part of the sympathetic and parasympathetic nervous system. The sympathetic nervous system is the system that helps us calm down. If it was totally dominant between those two, well, we would just sit on the couch like a slug. We would not be innervated enough to do anything or to want to do anything. So these systems need to be in balance or be able to come back to balance. The parasympathetic nervous system, innervating all the organs of the body, stimulating things like stress hormones, getting us ready to fight or flee, or creating such a disturbance that we feel like we just have to freeze in hope that nothing will happen to us that way. So it produces that fight-flight response and faint-freeze responses that are responses to experiencing triggers that take us back to the traumas if it's happening now. So the management strategies for trauma can engage the sympathetic nervous system through the vagus nerve to bring our nervous systems back into balance and calm those parasympathetic responses. The upper triad of the vagus nerve, and that has to do with striated muscles of the face and pupil size and all sorts of things, is really, really important because it's myelinated. And that means that signals travel back and forth between the brain and parts of the body very rapidly. But that's also why someone who is calm and centered and sitting in front of us and looking us in the eye, that people can respond to that by their own upper triad of the vagus nerve calming down. And that's what we do with children. You know, our child gets hurt, what do? We kneel down, get eye to eye, present as calm a presence as possible, even though we're freaking out inside, and say everything's going to be all right. So, EMDR can help to heal the trauma so the triggers cease to trigger fight, flight, faint, freeze, and other things. Next slide. So, new therapeutic strategies offer much more hope for healing than we ever had in the past. I worked for years in crisis intervention and in addiction, and we had really nothing that would fix it. We had management strategies, but lots of people would not find those helpful, or because they didn't fix it. So EMDR was created in 1989 by Francine Shapiro, and it was the therapeutic community was highly skeptical of it, including yours truly, until finally I got curious enough to take the training and started to use it and begin to see minor and major miracles on a regular basis in doing this work. So the EMDR therapy relies on an 8-stage model to reawaken the brain's natural capacity for healing itself. Starting to do EMDR was a revelation to me because I thought, it was humbling, I thought that I was more of an agent of change with my clients. When I started doing EMDR, I realized I was just more a facilitator of that. And I came to trust that the healing power within my clients could reemerge in order to help them recover from trauma. The result of EMDR work is often a very different perspective on the past event, newfound ability to put the traumatic event in the context of our entire life's experience, resulting in the relief also from the triggers that produce the psychological activation that makes us so uncomfortable. Next slide. This is a picture, it's a picture of the same brain, but on the left side what you have is before EMDR, before 4 EMDR treatment sessions. And you can see there in orange, that orange red is all over the brain. And that represents too much activation in those places in the brain. Our circuits are literally scrambled. Because when those neurons are firing too often, there's little cooperation between structures, little communication, and it's hard to think straight because we are dominated by that limbic system response. And the scan to the right is after 4 EMDR sessions where you see very little of that activation. So we know from these kinds of scans that EMDR changes the brain, which changes our emotional responses. And we also know from EEG studies while people are doing EMDR that different parts of the brain begin to communicate with each other through EEG waves, essentially. So we don't know exactly what we're doing when we do EMDR, but we know it changes things for the better this way. Next slide. So EMDR therapy is an 8-stage process, and you can find this online if you Google 8 stages of EMDR therapy. The first part is history taking. You know, we want to get grounded as therapists in where you come from, what your family was like, and whether you have any other trauma history besides the one that you're presenting to us that you want to work with. And that also is a trust building process, hopefully, of my clients getting to trust that this is something that can work for them. Sometimes diving into the deep end of the trauma pool is a very daunting thing and takes courage. And so some sense of safety with the therapist is essential for people to muster that courage to go through this process. The client preparation, step 2 or phase 2, that's all about helping create management tools for feelings. We do things like safe state and safe place. We begin to use in that phase also bilateral stimulation. Bilateral stimulation, even though the name of this process is eye movement desensitization and reprocessing, we come to find out that other forms of bilateral stimulation can also be effective. So the visual bilateral is simply, if you're watching my eyes, is crossing, I hold up a pointer generally, and follow it with my eyes, and what we want is to cross midline like this. When we're doing client preparation work, which is trying to anchor in images and thoughts and feelings that are safe and resourceful for us, then we go slowly. When we are in the desensitization phase, phase 4, we go considerably faster. We can also do this though with tactile stimulation, and I have a little device that has 2 things you hold on your hand, and it just buzzes both hands gently. But we can also have people do their own bilateral stimulation. We call this a butterfly hug. And under certain circumstances, we advise people to do this, but very slowly, because we don't want them to start processing their own trauma. So preparation is both, the purpose of that is to be able to manage symptoms better until we get done with it, to manage any thoughts and feelings that come up between sessions, and to use this as a backup, to call us if that's not working for people. The assessment phase is identifying what is the specific event that we're going to work with, and if possible, is there an image associated with that event? And we use that image as a touchstone image, because we're going to ask then, how distressing is that picture on a scale from 0 to 10. We call that the subjective units of distress scale. And so that gives us a number to start with, and that lets us know as we move through the process whether we're lowering that number in as speedily as possible. So we also ask, is there a negative thought that goes with this about yourself? Is there an affirmation that you don't believe very much or don't believe at all that you think would be helpful to you now? How much confidence do you have in that belief on a 1 to 7 scale? 1's not at all, 7's absolutely. And we ask what the feelings are that you have, and where do you feel them in your body? Where do you feel the event in your body? And that's a way of sort of bringing up the material to make it all available for reprocessing. And then we start sets of bilateral stimulation. Often that's from any place from 15 to 30 repetitions. And then we check in after each set, and a lot of things can go through your mind, lickety-split, thoughts, images, feelings. But we really want to know, when we're checking in, where you wound up. In talk therapy, we would be stopping at every thought, feeling, and talking through that. Here, it's very different. You don't have to concentrate on something really awful for a long period of time. We're really just trying to help you move through it, help your brain take the natural path that it needs to get to healing. And most of the time, once you tell us what you got at the end of the session, we say go with that, and we just go again. Periodically, we check in with that 0 to 10 number, and we see whether we're reducing that. And our hope is that we will get to a 0 or a 1 at the end. There are also, during those sets, the client is not communicating with you. The therapist is just taking a look at everything you can glean from, what your face looks like, what feelings you might be having, are your hands or your feet moving? What's your breath like? Are you breathing? Is your breathing deep? Is your belly rising and falling? All these things are information for us to assess, what we might do. And sometimes we will say something during a set that we hope will facilitate that processing. So once we get done with desensitization, we do the 5th step, that's installation, where we're pairing the desensitized event at a 0 or 1 with the affirmation that you gave us at the beginning. And then we do a few more sets, and usually that confidence in that affirmation will increase, which often helps to restore self-esteem that has been damaged by all of the collateral damage of trauma. And then we do a body scan. I ask you to go through your bodies, notice whether there's anything that feels bad or amiss. If you find something, we do a few more sets. Usually we can process it out very quickly. When people find positive things, I'll usually use that for the 7th step. It's like, well, just notice that better feeling that you have, that more relaxed feeling, that more calm feeling. And I'll sort of reinforce that as a way to help sort of close things down some more. Usually there's been down regulation of the parasympathetic system significantly from the process, but if we can get a little more out of that, get a little more of that before the client leaves, we like to do that. We also just evaluate the effect of it. But, if we have good numbers, lots of confidence in the affirmation, low distress scale, we like that, but say to the client, look, what's important is when you go out of here, that in your daily life, things that have been troubling you are changing. And so we ask people to keep a record of that, because it tells us, to what degree this session was successful, or it may tell us that we have some other places to go for more EMDR in the next sessions. And then when you come back for the follow-up session, we want to recheck that distress scale number and make sure it's holding. Sometimes it pops up a little bit. Usually we can work it down and it stays that way. Next slide. Yeah. Let's see, where are we in time? So, just a little bit about this. Back in 2007, this book came out, The Brain That Changes Itself. It was sort of the revelation that actually the brain is plastic. The brain adapts to what we learn. And if the symptoms of trauma persist, basically the brain adapts to that. So it's easier and faster to get to the unpleasant effects of being triggered. And what we want to do is change that structure to whatever degree we can. And that happens. Let's see, I'm going to come back to that in another slide. But so this book was written 8 years after Francine Shapiro created the therapy called EMDR. And it began to explain a lot about how EMDR therapy changes the brain and changes the mind. So what we know is when the brain is challenged to new learning, next slide please, all psychotherapy that is worthwhile will challenge us to learn new things about ourselves and about how to deal with issues in more effective ways. I would mention that there are several other methods. I'll come back to that. But if we move the large muscles of our body on a regular basis, we produce the raw material for growing new neurons, and so we grow new neurons, or the brain co-ops unused neurons near the site of where that learning is taking place in the brain. And this begins to happen after 30 days after somehow we have changed our minds. And then we begin to develop more neurological support for the new behavior or the new experience of ourselves that can come about from EMDR. Next slide. That gets into, we'll go ahead with that just for time's sake. So I'm going to talk again about EMDR if we have time. I'm going to be talking more about how do you find an EMDR therapist and how do you check them out. But if I can't get to that, it'll be in your presentation. You come back to it. It's pretty straightforward. So medical trauma, it's a sleeper. A great deal of just plain old PTSD is underdiagnosed in our culture. And medical trauma is even less often identified as trauma in our culture and in our medical systems. So the Diagnostical Statistical Manual and Statistical Manual of Emotional Disorders, which comes from the American Psychiatric Association, lists the first criteria for the diagnosis of PTSD as exposure to actual or threatened death, serious injury, or sexual violence in one of the following ways. And the first thing that's mentioned is directly experiencing the traumatic events and a diagnosis, and the idea, threatened death. So if you think about a cancer diagnosis, even if it's not an immediately life-threatening illness, like I suppose prostate cancer, very often it's that, there's still threatened death in that. There's threatened death in every form of cancer. It's the first place the mind goes, probably, when we get a diagnosis of cancer. So by definition, by the official definition, it's trauma. Next slide. So additional criteria cite several types of trauma as examples, but egregiously omit medical trauma, which reflects that a lot of therapists don't pay attention to medical trauma or don't see it as traumatic. So a cancer diagnosis is just the beginning of a series of potentially traumatic experiences. Doesn't mean they're necessarily that, including waiting for a lab or biopsy results that often is required before you begin treatment, well, generally that's an incredibly anxiety-provoking experience for people. And the longer the wait, the worse it often gets. Then there's the side effects of chemotherapy or radiation that can affect every aspect of your life. That can be traumatic. Next slide. And then there's the uncertainty about the outcome of surgery, chemotherapy, or radiation therapy, and presumably often, or maybe most of the time, that threat of death that goes with that. And there's the disfigurement and trauma to body image resulting from mastectomy or surgery on unclothed visible parts of the body that people see in our everyday life, which can be a sense of feeling painfully seen and somehow feeling transparent, which is generally a very uncomfortable feeling. Like people can see that you're really, people usually can't see how uncomfortable you are if you are, but it can feel like they can. And that's very difficult. And then there are the anticipated losses that go with projecting a bad outcome for treatment, which it's easy to go there, like birthdays and anniversaries and graduations, etc. Next slide. Then there's the loneliness of the experience of cancer and cancer treatment, because we may fear that those who've not had the experience themselves or through loved ones will not understand the emotional and physical pain of your experience. That's also true for many traumatized people, who are having repeated and ongoing and long-going symptoms that they're afraid people just won't understand this. And in general, our culture doesn't tolerate taking a long time to grieve, which grief usually takes a lot longer than people expect it to take, or heal from emotional or physical problems. We just don't tolerate that very well, and so we may have the sense that people are making judgments about us if we talk about these things. Next slide. Adding insult to injury, implicit diminishment by hospital systems. So, to whatever degree this is happening, a burden's placed on top of the physical burden of recovery. And one would think that the medical profession would have developed ways to mitigate the emotional consequences of a cancer diagnosis, and I'm not saying that in some places they do. But I'm not sure how often that's true. And so one might think that the medical profession would find every way possible to respect, honor, and respond well to cancer patients. But to whatever degree you're looked at as a diagnosis rather than a person, and surgeons, some of them, maybe many of them, sort of look at things that way. I mean, if you have a surgeon, you may have a pre-consultation with them, and then you may go to surgery. You don't really have time to develop a trusting relationship with them that might make it feel safer to go to surgery. Now, there are exceptions to that too, and I know that. Next slide. So again, I want to say undoubtedly there are medical professionals, and I've heard about them from clients, who do really well at mitigating emotional consequences, respecting and responding to you, answering every question, staying present to you while they're doing so, and not looking at a computer screen. On the other hand, the last 30 years have seen medicine converted from a service model to a business model. And that means procedures are widgets, and the whole system expects as much production of widgets as possible, and that has resulted in, we used to have at a community hospital, we used to have patient representatives their sole purpose was to listen to people, solve problems. They don't have that anymore. That's not cost effective, and insurance doesn't pay for it. That's what you'd hear. Next slide. So providers might want to respond well to cancer patients, but the hospital systems that employ them may not want to provide help. I mentioned that. that is not billable to insurance, which is just that phrase just makes my stomach turn whenever I hear it. Because of this transition to a business model of healthcare, procedures are valued above all else as sources of income. Preparation for procedures, for surgeries, and discharge planning after these procedures and surgeries is often cursory and inadequate. And I know that from talking to my own clients. I mean, people are often very unprepared for what it's going to be like to go home, and dumped out of the hospital very, very quickly when, many years ago, people would be in the hospital for 4 or 5 days. They would get a PT consult, they'd get an OT consult, they would talk about every aspect of your life in your home and how to manage, recovery in those places with strategies that will work better for you and be less painful. Next slide. So the result is extremely short stays, discharged from home often without adequate resources and information to deal with the consequences of treatment. Then there's electronic medical record keeping. It's implicitly diminishing to us. In the past, your physician looked at you, looked at your body, often laid hands on you in a physical exam, and the cost of physicians not laying hands on us very often is really, really high. Human touch is implicit communication that I care about you. So hospital systems all use EMR. Physicians are required to record while they work with you, talk with you, which means they're not looking at you. And you remember that upper triad of the vagus nerve system. If you're anxious or worried about what's going on with you, you have less face-to-face time, less eye-to-eye time to be reassured. If your physician is capable of doing that, they simply may not have the time to do that because they have to do too many things. I might mention also that EMR is famous for including a whole lot of detail that has to do with Medicare or insurance, and so the physician trying to find previous notes about you can be daunting and time-consuming and something they just don't do because they don't have time to talk to you and keep that record, etc., etc. So, decrease in eye contact matters to our neurology and therefore our psychology. Imaging and lab tests are taking the place more and more of laying on of hands by physicians. And I mentioned the vagus nerve and why that matters. There's the upper triad. The upper triad, I think I said, had myelinated fibers. So very quickly we can respond to somebody who's reassuring and calm. There's also much reduced communication between medical providers and patients, and medical providers. If you have a group of physicians that's treating you, it used to be that they would see each other in the doctor's lounge. I know, and I think this happened in other facilities, I know community hospital eliminated the doctor's lounge. But what happened in there was physicians who were treating the same patient would have informal, brief conversations where important medical information would get communicated and your care would get sort of informally coordinated. Also, now we have hospitalists who don't know us at all, who only treat people in the hospital, and they've taken the place of our family physicians who used to make rounds on their patients who were hospitalized. And they used to take a bigger part in coordination of care. And they surely were instrumental in reassuring their patients about the other physicians and the processes and treatments that were taking place. Next slide. So, there's the diminishing role of family physician. There's the diminished communication between the multiple providers of your care. There's diminished eye contact. There's the increasing role of the hospitalist. And there's also the expectations of new graduates of medical school are much, much different than they used to be. And certainly we can make the case that physicians work too hard in the past, and at great cost probably to their families. But on the other hand, now we have people that expect that their day is going to be 8 to 5 or 9 to 5. And so there is, I think, some sense, particularly if we're older and we've had sort of other kinds of experiences, there may be some sense that the physicians care less about us because of that. Next slide. So the overall result is a significant decrease in the opportunity for physicians to build trust with you and for you to come to trust them. And good healing depends on a reasonable sense of safety. And all these things are important to feeling safe. I say to my clients basically, nothing changes, at least emotionally, in the absence of safety. That's about trust in me, trust in the process. It may be about other emotionally supportive people. All those things matter to trust. But we have a lot less ways of developing that with our medical providers these days. Next slide. Well, I just went through that. Let's go to the next slide. So I'm going to skip this part. So this is how to find a provider where you live, and I'm going to submit a modified version of this to make sure I have the right link in here and a couple of other things, so that when you get your, well, you're going to get a tape, I guess. But if you get the PowerPoint, some additional information will be in this. I'd like to stop now and give you adequate time to ask questions.
Thank you so much. We do have a couple of questions here. Let's see. So thank you for the opportunity to learn more about EMDR. Are there particular patient populations for whom EMDR should be considered over other non-drug approaches like psychotherapy, narrative therapeutic writing, etc.?
Well, in the EMDR therapy community, and I tried to say this, and maybe it wasn't clear. We value management strategies, and certainly narrative therapy, journaling, mindfulness, yoga, all these things can help manage trauma, but they may not fix it. And I used to say to my clients, look, I think we can help you. And then I sort of modified that to, I'm sure we can help you. And then I kind of modified that to, I think we can fix this. And then I modified that to, we can fix this. So we teach management strategies as a part of this strategy. In the neuropsychology community, now, if you listen to any of them, they're talking about mindfulness and all sorts of strategies that we all need to change our brains. We all need to develop a better capacity to downregulate our systems. So talk therapy can be helpful to trauma. It can also be re-traumatizing. If somebody has to tell their story over and over again and they're not getting significant relief when they do, they may be re-traumatized by the telling instead of helped by the telling. And that's an individual thing. In terms of populations, when we started, we sort of limited it to officially defined trauma, but now we find sometimes it can be helpful to other things like OCD and addiction, because our new understanding of addiction is that very often people who become addicted had emotional dysregulation in childhood. In other words, their childhood was very unpleasant. So we've expanded that definition, and often if people present to me with anxiety or phobia, for example, usually we can find a trauma that was responsible for the development of that phobia and treat it with EMDR. So I'd say, we've expanded the universe of what we think EMDR can be helpful to.
And is it more effective? I mean, you just said it may not even treat or worsen the trauma, right? The PTSD and trauma through traditional talk therapy, but is it more effective and does it happen quicker with EMDR therapy that a patient would overcome the trauma?
Very good question. So, and this is one of the hardest questions that therapists have to answer, which is, well, how long is this going to take and how much money am I going to have to spend and how many sessions? But in general, I would say, compared to talk therapy, treating trauma, we can go way faster. Because in talk therapy, you're going to pick apart every little part of it and talk through it. And in EMDR therapy, the analogy they teach us in the training is, look, if you're going to get on a train and go to Chicago, the goal is getting to Chicago. But you may get on the train, you look out the window, and you see the scenery going by, lickety-split, and you don't have time to really examine what you saw. And that's what processing is like. We don't care to examine every little thing that happened in the mind like we would in talk therapy. We just want to get you to Chicago where you'll feel better. So I find that a very useful analogy, and I repeat it to clients all the time. So yeah, we can do things a lot faster for trauma than, and I don't know what to say about trauma-informed cognitive behavioral therapy. I use cognitive behavioral therapy, but I'm not trained in trauma-informed cognitive behavioral therapy.
Got it. And while you were talking too, I was just thinking about how important, and I don't know that every cancer patient can appreciate how important it is to diminish the fight or flight response, right? And because that can have future implications in health, right, going forward. And so do you have any comments about that?
Yeah, I will often do a combination of a relaxation exercise and really hypnosis. But how I begin is by taking through the relaxation response as it was outlined over 40 years ago by Herbert Benson. And that's starting to attend to the breathing. And then and using some strategies to help deepen breathing naturally. And then talking about the circulatory system, which begins to entrain to that change in the breathing system. And capillaries expand because blood moves from inner to outer, and then you may feel a pleasant feel of warmth, and then something happens to the muscular system and to the endocrine system. So we're trying in that process to bring the body back into balance because it's stressed, and presumably healing takes place a lot faster when we can do that. And if we are traumatized, it will keep us in a state that is less conducive. It's even if you just think about this from a circulation standpoint. If you're stressed, if you're in shock, the blood all goes to your center and it's not available to your periphery. It's not available to take nutrients to different places, to take toxins or byproducts of inflammation that may have occurred from, well, may just be there or may have occurred because of the trauma. And so just that one thing could be really important to healing.
Something else from one of your earlier slides that I was thinking about too is, we know that there's chemo brain, that chemotherapy can often affect the brain's ability to function as it did before. We offer a neurocognitive therapy here to address that. But I wonder too how much of those effects of forgetfulness, inability to concentrate, it could be just from the trauma, right? From the trauma of that cancer diagnosis and all of the repeated trauma throughout the treatment.
Yeah, and that's a good point also. It's when you looked at symptom categories for things, there's lots of overlap between problems. So I would think there would be a great deal of overlap between chemo brain and trauma symptoms. When people come in and say, I think I have ADD, I want to look at anxiety, depression, and ADD symptoms because the overlap between those symptoms is considerable. And you want to be informed about every part of that in order to be discerning about what the problem really is and how to treat it. So You know, a trauma screen is a good, I mean, I basically screen everybody I see for trauma, whether they present with it or not. Because sometimes it informs me that we need to do trauma resolution to help with the problem the client is presenting with.
Oh, thank you. I was just looking through some of our questions here. We've got one here. Absolutely loved this. We offer certain spa treatments, touch, for cancer survivors, also for rehab body image, together with equine therapy for PTSD outdoor movement. I could listen to Dr. George for longer. He sees the missing link in the circle of care.
Oh, thank you. Thank you very much.
Okay, and then we have another one here. How can we change the healthcare system that needs help and has lost its way? And I think this person asked in the other box something similar. Let me pull it up. I think you talked when you were talking about the widgets. Yeah, so in the other box, he says, how can we change the healthcare system so there are no widgets? So what do you kind of see as those holes in our traditional healthcare system, and how can we might address those holes?
The healthcare system needs to not operate on a business model. It because it does so, it takes the humanity out of it. And some people some providers will fight through that and provide you with their humanity. But as long as it's oriented that way, systems and providers, everyone, is going to be cajoled, forced to not be as present as we need people to be present when we're in trouble of any kind. So, the idea of a one provider system, well, that takes the business model out of it to a great degree anyway. So I think our healthcare system needs to be transformed in every way to move it away from the business model and back to community hospital, which is where I work here in Indianapolis for many years, 15 years. That institution was founded because physicians wanted to deal with the patients in their own way. And the guy that ran the place, the CEO, was somebody who knew every 3,000 people's names. I mean, it was that. So the way employees were treated and honored and known was huge in the kind of care that was provided there then. And I was a beneficiary of that care. I had a surgery at 29, back surgery. I was in the hospital 4 weeks. And to a great degree, I experienced that kind of care. That just doesn't happen anymore.
We kind of have touched on this, but is EMDR one and done, or do individuals need repeat visits throughout time? Maybe just give a little bit more detail about, you took us through the steps, about how long, or is there an average?
Well, it's hard to answer that question. What I would say about single episode trauma is we do an evaluation session, a history taking session. We might do a preparation session, that phase, and then an EMDR session, and then a recheck. So it can be that brief. If that one session takes care of it, which often it does with one single episode trauma, it can be, 4 sessions, 5 sessions. But the more trauma there is, the more complex it is, the more things that have happened to you that are traumatic, the longer the process is going to take. Now, that said, I had a person a few years ago who came in, and when we made the trauma list, there were 12 things on it. And the funny thing so we have a choice. Do we deal with the worst, or we deal with the first? And the argument for dealing with the worst is that's usually what's troubling people the most, and maybe that symptom relief will be really valuable. The argument for the first is, if we start there, very often what happens is other things get rolled into it. And I think we stopped after 6 sessions because when we rechecked the distress scale on other items that we had not directly addressed with EMDR, they had been sort of rolled into the processing that we did already. So that's great when it can be very efficient that way. We may not need to address directly all of the things that have been traumatic for us when we have a list like that.
You mentioned the importance of eye contact and touch as tangible strategies for medical professionals. How can clinicians, oncologists learn how to improve their interactions with patients and survivors to reduce the trauma?
Well, certainly eye contact is extremely important. The sense that we are being seen for who we are, what we feel, what we're afraid of. If the reassurance is mechanical and memorized, and, it's not going to register with us as care, or compassion, or so. So eye contact is really important. Frankly, the closer the physician can get to not standing over you, but look, but at your level. A calm demeanor, even though they may be rushed, you get a sense that they're willing to answer every question. My family doctor will say, "Well, anything else going on after we present my problem?" Well, I find that very helpful because I go, "Well, yeah, there's this." So, but that also engenders a sense that he's not rushing out of the treatment room to go to somebody else, which doesn't engender a sense of safety and trust. Does this make sense?
Yeah.
So listening, being fully present, which is the best thing any of us can do for anybody that's in trouble. Not advice, not any of that, but feeling like we are seeing and hearing and with our whole selves, whether that's physicians or other people, that's generally what's the most valuable kind of support is.
Great, thank you. We're just about at the end here to wrap up, and then I'll just read one last comment here. Truly one of the best talks ever, as I feel about this entire seminar. I'd love for all medical students and residents whom I've had the privilege to teach over the years to be able to see this. So
thank you very much.
Well, thank you so much for joining us. Your insight has been invaluable. I think it's, to learn about EMDR, not everybody knows about that type of therapy, and we would love to be able to offer it here at Karuna Precision as well. But so thank you for coming in and informing us all today.
My pleasure.
Okay, so we have one last presentation here for the end of our session. So we're going to take another 5-minute break. It is 2:48. So at 2:53, we will come back with Dr. Anthony Magliocco. Thank you. Okay, welcome back, everybody. Thank you so much for sticking with us. We've had a long day today, but we've just been packed full of great information. So I really appreciate you sticking with us for our last presentation by Dr. Anthony Magliocco, and I hope I'm saying that correctly. Dr. Magliocco, you can correct me if I'm wrong. But our final speaker today is Dr. Anthony Magliocco, a board certified pathologist and professor of oncology and pathology with over 30 years of experience in tissue pathology, medical research, molecular diagnostics, liquid biopsy, genetics, digital imaging analysis, and clinical trials. He has founded and led multiple clinical laboratories and has overseen the deployment of numerous new laboratory tests in his career in both Canada and the USA. He has published over 200 research articles, has numerous patents issued and applied, and is a frequent invited speaker to international diagnostic technology meetings. He was chair of pathology at the Moffitt Cancer Center, scientific director of the tissue core at Moffitt, and chair of pathology in the national cooperative groups RTOG and NRG Oncology. In his extensive peer-reviewed research, he has developed new digital image analysis methods and has created numerous new diagnostic tests used to aid selection of treatment plans for patients with breast, ovary, lung, bladder, and many other cancers. He founded fellowship programs in digital imaging and molecular diagnostics at the Moffitt Cancer Center. He founded the hereditary cancer program in Saskatchewan and was the pathology leader of numerous tumor groups at the Tom Baker Cancer Center in Canada. He also served as medical and scientific director of multiple regional and national tumor banks. His deep knowledge of molecular biology and medicine enable him to identify tests and tools that are unique in their ability to contribute to the future of medical diagnostics. His interest and aptitude for business enables him to create a viable pathway for implementation of these tests and tools. His vision is to move medical diagnostics forward to keep pace with scientific discoveries. Most recently, he founded Protean Biodiagnostics and raised multiple rounds of funding. He has developed the unique oncology MAPS system, currently the only comprehensive precision medicine system aimed at supporting community-based cancer patients and their doctors. He is the principal investigator of multiple ongoing biomarker-based clinical trials. Please welcome Dr. Anthony Magliocco.
Thank you for that introduction. It's a pleasure to be here today. Happy to get started and give you a quick overview of some of the advances in precision medicine for cancer care. So am I controlling the presentation, or I don't have it in front of me right now?
I think we can have Candace pull it up here if you need her to.
Yep,
I can run it from my computer if it needs to be as well. So let's go do that. So can you see my screen?
Yeah.
Oh, sorry. Yeah, sorry for that. It's like glitch. So today I'm going to tell you a little bit about navigating the cancer treatments using precision diagnostics for oncology. And it sounds like you had a great symposium today. So thanks for inviting me, for joining. And today I'd like to talk a little bit about how patients, or how the new advances in precision cancer diagnostics affect patients, and how it's really important for cancer patients and their loved ones to really learn about this and to somewhat take ownership of it, because the field is moving so quickly that even the medical professionals are having difficulty keeping up. So as noted, I'm from Protean Biodiagnostics, and Protean is really aimed, the mission of Protean is to really help mostly community-based providers and patients really access the promise of precision medicine. Now, if we think about what is precision medicine is probably one of the biggest advances in medical care in really forever. And what it is It's the ability to apply technology to really understand the individual, so that back in the old days, it was basically one size fits all treatment. Whereas we know now that with a complex disease like cancer, every patient is different. They may have different subtypes of cancer, they have different morbidities, and so on. The whole idea of precision medicine is to match cancer patients to the correct treatment before you even initiate the treatment. You can imagine if you take all of the cancer patients, which are quite a heterogeneous or mixed group, and were to treat them with one type of therapy, you would only get a percentage of response in a subset, perhaps 20%. But if you had a tool that could identify those group of patients that respond in advance, you could pre-select them and really target your therapies to the groups of patients that are going to respond, avoiding toxicity in the non-responders, and really getting maximum impact from a new therapy. And most typical new therapies will only affect response in a subset of patients. So one of the real goals is understand how to identify patients in advance. So some of the more recent advances are something called targeted therapies, which are special kinds of cancer therapy that really target subsets of cancer patients and essentially can treat them without causing toxicity in other organs. Another class of therapy that's come around is something called immunotherapy, where we've learned how some cancers evade destructions from the immune system, but that we can reprogram the immune system or shut off the defenses of the cancer with therapy to allow the immune system to take over and destroy the cancer. And there's a lot of excitement around immunotherapy and making it more broadly available. Another area is radiation therapy. Surprisingly, radiation is used quite broadly, but it may only benefit a subset of cancer patients. We're starting to learn, how do we identify the patients who will benefit most from radiation therapy? And also, can we adjust the radiation therapy to make it more effective in the patients that it's not working with? The culmination of all of this, all of these rapid advances, is that we now have a dramatic need for new diagnostic services to better match patients to potential therapies. And this is where biomarker testing comes in. So we have the group of patients who are diagnosed with cancer. We're really using advanced biomarker testing or lab testing to sort them out into the groups that are most likely to respond to specific therapies. Now, if we look at how therapies have changed over the years, the chart on the left shows the number of FDA approvals for new cancer therapies. And for decades, there would only be 1 or 2 new therapies approved a year. Since 1990, this has shot up dramatically. And actually, in the last year, I had a quick look. There were 56 new approvals from the FDA. So there's more than one a week now. And I'm signed up for alerts. I get alerts pretty much every day about a new potential approval or a new approval being considered by the FDA for therapy. What this means is that the number of lab tests required to match those therapies are exploding. This graph shows you how many new lab tests are coming into use every year. It's increasing at a 20% rate. And then the chart on the right is an effort to show how complex the decision-making process is for doctors. So the red dots are cancer, the green dots are the drugs that are approved for treating that particular cancer. So there is a lot of choice, and the real challenge is, how do we pick the right treatment for the right patient at the right time? Now, where do patients get the best care? They get the best care if they go to something called National Comprehensive Cancer Network centers. There's only 52 of them in America, and only about 5 to 12% of patients actually go there. At these centers, they get multidisciplinary care, they get access to the latest diagnostics, and they get enrolled in clinical trials. It would be great if all patients were able to access that. The fact that they don't is creating one of the gaps and barriers in American healthcare. And this is unfortunate in that the vast majority of cancer patients actually live in more rural areas or distances away from these academic medical centers, and 85% of patients are treated in non-academic medical centers. If we look at this as a potential gap, we're actually seeing now that, for example, lung cancer patients, where it's recommended that every cancer patient get an EGFR test, we're now seeing that more than half of them are not getting the testing they need. In addition, if we review cancer patients, their primary pathology, over 30% of them have incomplete or inaccurate diagnostic reports. Less than 5% of patients get enrolled on clinical trials. And this is a real problem because there are actually thousands of clinical trials available. Getting on a clinical trial improves the outcome of cancer patients, and it can reduce costs. It can also generate revenue for medical centers, for physicians, and it definitely increases the knowledge, the human knowledge regarding cancer, and creates new treatment opportunities. One of the more concerning discoveries as well is that over 60% of community-based oncologists admit that they're confused and uncertain of what tests to order and what these tests mean when they get the result. Now, these are the group that admit that. There was a further study that showed that even when the correct test was done, that over 25% of the oncologists didn't see the result or didn't know how to interpret the result. So this is resulting in what we consider a growing gap between the academic medical centers and the community cancer centers. And this is a problem that we and others at Protean is really focused on. How do we close this gap and really make access to cancer care more effective for really all patients? Our approach was to create an integrated system to really make cancer diagnostics easy for community cancer specialists. We essentially have a lab that can perform all of the testing or coordinate the testing with other specialty labs so that we can assist the community oncologist or the patient get the testing that they need. Now, how do we decide what testing is necessary? So there are something called the NCCN guidelines where approved tests are updated by experts, and those are made available on a frequently updated basis. So we create a test selection really based on best available guidance. It's optimized and it's different for cancers of different types. And best of all, it's mostly covered by insurance. So these are standard treatments. These are standard diagnostics. And we're really trying to close that gap to bring standard diagnostics to patients everywhere. And like I said, somewhat shocking to understand that more than half of cancer patients are not even receiving standard diagnostic services. Now, when a patient, when a practice moves from the old school, this is what I call the old school way on the top. This is the journey that a patient in the community frequently goes through. They have a primary care provider, they may get an X-ray, they go to a surgeon, and then they go to a community oncologist. All of these people or centers are often not in the same center or separate. When they turn up at the community oncologist, the oncologist decides to order a test, and it may take up to 6 weeks to organize that test and get the result. They may not be able to understand the result when it comes back, and then they will basically refer back to outdated treatment options, and you get the same outcomes that you always did. However, if you use a more innovative system like the one that the Protean is endeavoring to promote, that once the patient arrives at a community oncology center, the Protean system can produce results within 2 days and assist the community oncologist in selecting the most recent approved therapies, continuously update the response to therapy, adjust as needed, and get patients onto clinical trials when appropriate. So this new way of doing adaptive precision medicine is the way to really improve outcomes in cancer patients. And it really brings the advances that are only seen at academic medical centers and makes them available to cancers everywhere or to patients everywhere. One of the key components of this is something called a virtual tumor board. So at the major academic medical center, about 13 times a week and sorted by each cancer type, the entire care team gets together to discuss all of the cases. So the surgeons, the radiation oncologists, the medical oncologists, nurses, support staff all get together and review the pathology, radiology, and make treatment plans. Now, in community centers, this doesn't happen because the community oncologists, they can't get together with the surgeons easily. They're both busy. It's hard to pull them all together. So we've worked with Roche and others to devise a system, electronic system, where we can recreate the experience virtually, where they can log in over time, so it doesn't have to be at a specific time. The tumor board can be open for several days. It's populated by the information that they need. A pathologist and radiologist can attend. The tumor board is actually supported by guidelines so that the guidelines are built in, and the clinical trials that a patient might be eligible for are built in as well. The nice thing about this is that it can be opened up to other doctors. So if there's an expert in another state or other city that can be invited in to review the case, the system documents the case, which is useful for medical legal purposes. It maps out the case. The documentation is also useful for insurance providers who, when it goes through this process, are more likely to pay for the approved therapy, given that the decision for the next steps were made in consultation with a group of experts in accordance with guidelines and best available evidence. So we think that the tumor board system or the virtual tumor board system can really transform the way that cancer care is given. In addition, we often work with private patients who are seeking second opinions, that they'd like to come and have us review the case or help them pull all of the data together, which we can do, and really help them confirm that they're on the right treatment path. Or if they wish to seek another opinion, another center, once all of this information is all bundled up, it's very easy to make this available to another center so that another oncologist or another center might have a clinical trial that's open for this particular patient. So we think that the virtual tumor boards brings advances not only for the community cancer centers and the community oncologists, but also for the patients separately as well. So it really creates a win-win situation. And it also opens up more opportunities for patients to engage in clinical trials. Also, the fact that this is done in a very standardized way and is powered by guidelines makes the payers quite happy as well, because they have some confidence that proper care is being given, and that when therapy is recommended, that it is actually indicated and that it's made by consensus decision among experts. I'm going to tell you a little bit about what happens to your specimen after diagnosis of cancer or during the diagnosis of cancer. So typically a cancer is diagnosed and then removed by a surgical team. So here we see a surgical team removing a specimen in the operating room. The specimen is frequently placed into formalin solution. So the formaldehyde solution is designed to really stop degradation of the specimen. So once the specimen is in formaldehyde solution, it's stable there for many days, so it can be transported at room temperature. What this does is stop the decay in the specimen and stabilize it, and so it can then be handled and examined later. In this case, it's now in the pathology department, and the pathologist is examining the specimen. They trim it down, select areas of interest, and place it into these plastic cassettes. These plastic cassettes then go through a processing experience where essentially they go through a series of chemicals, which further fixes the tissue and also removes water from it. That happens generally overnight. The next day, after the specimen is processed, so this specimen has now been processed, it's been basically dried out, and now the technician is putting it into a cast here, or a mold. So the specimen is being put into a mold, and on this device here, this device will inject liquid paraffin wax into this little mold. So this creates the paraffin embedded tissue block. And this is sort of the key component of cancer diagnosis. It's a very interesting thing. The paraffin block was invented probably over 100 years ago, and it's a way that cancer tissue is stabilized. So this is a piece of cancer tissue inside a wax block. And basically every pathology department in the world is full of these. There's millions of them, because they generally don't throw them out. So they're accumulated over time. So right in here is the piece of of cancer tissue, and it's very stable in there. So this is made the very first day after the surgery. Once that's made, here's the paraffin block put into a microtome, and a thin sliver of tissue is cut from this. So this device uses a razor blade or a very sharp knife to slice off very, very thin sections of the paraffin block and the tissue. And then it's floated in a water bath. So these are the pieces of, this is called a ribbon, because these are serial sections. Each one of these are 4 microns thick, or about the thickness of a cell, or actually half the thickness of the cell. So it's very, very thin. And so from a paraffin block like this, you can cut thousands of slides. So thousands of slides can be made with these very, very thin sections. So this is a tiny slice of the tumor. It's then mounted onto a glass slide. So here we see a glass slide. The paraffin wax is sitting here in the cancer. A very, very thin section of the cancer is there. It's then stained, because otherwise it's clear. We can't see anything. It wouldn't see anything. So the dyes that are used are actually dyes that were used in the silk industry over 100 years ago. And scientists back more than 100 years ago found that you could use these dyes to stain tissue and give them color so that you can actually visualize the tissue. So this is stained with eosin and hematoxylin. A little glass cover slip is put on top. And now this thing is a mounted piece of tissue that's stained. And this is basically stable for decades. So this can stay for decades. This slide is then sent to a pathologist. So this is your friendly neighborhood pathologist. This is Dr. Musa Khalil in Calgary, colleague of mine. And this is what a pathology department looked like about 50 years ago. And today it looks pretty much exactly the same, except maybe the monitor is upgraded and this is no longer a 386 computer. It might be a multi-Pentium computer, but the slides come on trays. The pathologist looks at it. There's 2 heads here. Another resident can look at it, and this is how a diagnosis is made. So it's in some ways it's a primitive process. The pathologist will look down, in this case, breast cancer, and determine what is the grade. So they'll look at it and say, is there tubules? What do the nuclei look like? How many mitosis there is, and get a score. Now, you don't really get to choose your pathologist. You might get a very good one like Dr. Khalil, or you might get one that you don't know who isn't really a breast expert. So often, your fate is in the hands of someone you don't really know that well and may have variable expertise, which is potentially an issue when dealing with pathology, because this grade is very important in deciding whether you're going to get chemotherapy or not, or how your tissue or how your tumor is going to be managed. In addition, there's something called biomarkers, and biomarkers are special tests that are done on the tissue or on the material that's extracted from a patient. The biomarker tells you what is the prognosis. So will this cancer metastasize? Will it come back, or is it cured? It will predict what therapy will be best used for this cancer. And it might also tell you whether or not a therapy should be not used, because some therapies are toxic in some patients. In fact, some therapies may kill a patient due to genetic predisposition to sensitivity to certain therapies. So an example of a biomarker is estrogen receptor, and we know estrogen receptor drives breast cancer. It's been known for well over 50 years. On the left is a piece of normal breast tissue. We've stained it with a dye that sticks to estrogen receptor. It's basically an antibody. And we can see that within the normal cells, a subset of them show red staining. This indicates that these cells have estrogen receptor present. In this particular cancer over here, the cancer of these cells around the outside, they're very, very strong for estrogen receptor. So cancers that strongly express estrogen receptor respond to anti-estrogen receptor treatment. But again, the dye is done and a pathologist makes a diagnosis. They decide whether the tumor is positive or not. That decision guides therapy. Similarly for HER2, HER2 is another therapeutic, another marker for therapeutic for trastuzumab. Again, a dye is applied to the slide, and the pathologist decides whether it's positive or not. And that decision governs whether or not you're going to get treatment. That's all well and good, but sometimes if something goes wrong with the testing process, it can be problematic. Back in Canada, about 15 years ago, it was discovered that one of the Canadian provinces actually was doing incorrect testing, and they had done incorrect testing for over 10 years and no one noticed. And several hundred women were misclassified with breast cancer and received the wrong treatment. So this became really apparent and led to an investigation where it was discovered that labs really weren't working together. They weren't really determining whether their tests were working accurately or not. So now there's an interlab testing program. And the reason I show this is that it's thought that the testing is quite good. However, what this result shows, each column is a lab, each row is a case. The case is sent to every lab and each lab is asked to show the result. If it's red, it means it's positive. If it's white, it means it's negative. So in this case, case one, every lab thought it was positive. So that's great. This case down here, some labs thought it was positive and some thought it was negative. Now that's potentially a problem because if the case was analyzed at this lab, the patient would get 10 years of endocrine therapy. If it was diagnosed at this lab, the patient would get no endocrine therapy. So here we see that even though this is exactly the same case, and this shows some of the variation in the lab industry. Why does this happen? Well, it turns out that different tests are used at different labs, and sometimes the tests don't work quite right, and there may be problems with test standardization. So here we see 3 different estrogen receptor tests. This is some work I did in my research lab. We can see they're both positive here. And then if we look at a different case, we see that interestingly, in this case 716, that the estrogen receptor was found to be positive with all brands, but actually the progesterone receptor was found to be negative with one, even though it was strongly positive with the other. So there are different results with different methods. The point of this is that lab reports often contain errors as much as 44% of the time. And this is one of the problems in the lab industry that we really need to understand. How do we improve the accuracy of diagnosis? And also so that patients are aware that lab error does occur and that there is extreme value to second opinions and to shared work. So one area that's making an impact is digital pathology. So with digital pathology, the pathology slides, you can see them here, are now scanned. And so the image is now converted into a digital image, which makes it very easy to share and to share with other pathologists so that it can be quickly shared to get additional opinions. It can also be utilized for artificial intelligence. So now we can get computers to help pathologists ensure that they see everything and don't make any errors. It's estimated that globally there's a shortage of almost 300,000 pathologists. So there'll never be enough pathologists to really do all of the work that's necessary. So the development of artificial intelligence is quite important. In addition, the ability to do more complex staining is also happening. So I showed you these other stains with estrogen receptor that were single color. They were only looking at one protein at a time. Now with new technology, we can look at multiple different kinds of cells, classify them very quickly on a single glass slide, and actually have a computer isolate them, count them, analyze them, and lead to very sophisticated and reproducible analytical methods. We saw when we rely on humans, they can be quite good, but some humans are not as good as others or not as experienced as others. Bringing in computer technology may help overcome some of the shortcomings of humans and really advance pathology to the stage where it becomes more quantifiable and more accurate. So here's an example where we can count every immune cell that's present in the tumor, and this can give us information about how best to select therapy for patients. Another area that's really exploded is molecular diagnostics. And if we look at what is molecular diagnostics, so DNA encodes the library. Every cell in your body has a complete copy of your genetic information. In fact, 2 copies, so one of them is sort of a backup. The difference between a liver cell and a brain cell is that different genes are used. So different books are taken out of the library in the brain cell compared to the liver cell. So there are 20,000 genes that are encoded in the DNA. in each cell, only a few hundred of them or a few thousand are used. So a liver cell uses different genes than a brain cell. The genes that are being used are converted into something called RNA that's transient. DNA is designed to last forever. RNA is designed to only last a brief period of time for when the cell is reading the DNA. The RNA is then converted into protein. So we can measure each one of these things. In a cancer cell, often something goes wrong with the DNA. It leads to alterations in the RNA and abnormal proteins, which lead to driving a cancer cell or converting a normal cell into a cancer cell. One of the biggest advances in human science was the unveiling of the human genome and the Human Genome Project, which was completed back in 2000. This was really a landmark achievement where we mapped every human gene and learned how many genes there were. There's about 20,000 to 30,000 genes. Some animals and trees have hundreds of thousands of genes. So humans actually have in some ways less complexity than other animals. However, the genetic information, even though you have only a few thousand genes, the RNA is converted into millions of different kinds of proteins. The proteins can also be altered in other ways as well. So even though there's a limited complexity to the DNA, there's much more complexity to protein and so on. If we look in the days of the Human Genome Project, human genome centers look like this. They were full of sequencers. There were buildings with floors full of this, and they'd spend day and night sequencing pieces of DNA, trying to put the human genome together. And they might be assigned one chromosome, and it would take them weeks and weeks and weeks to sequence a bit of one chromosome. Today, we can sequence a whole human genome in a lab at a very low cost. So there's been a massive explosion in our ability to now sequence. So this small device that sits on a desktop, it's pretty much like a coffee machine, replaces an entire building full of sequencers. So we've got incredible technology. The cost of sequencing back in 2000 cost about $100 million to sequence one genome, and now it's less than $1,000. Moore's law defines what happened with transistors and computers. Genomic sequencing has defied that law, and basically the cost of sequencing is almost 1 million times cheaper than it was. So incredible reduced cost. But what it does mean is with the reduced cost, we have much, much more data to try to deal with. So we can generate a lot of sequencing data, but we don't quite know what it all means yet. Now, where this is coming to play in terms of cancer, lung cancer is one of the cancers that was extremely problematic. A major proportion is caused by smoking, but there's also a significant proportion of lung cancer, maybe even over 30%, that we're not quite sure what is the cause, and it's really not related to smoking. Now, back if we look at the way we dealt with lung cancer 30 years ago, it was all really grouped together, and we only had to decide, was it non-small cell or small cell? And that defined what sort of treatment was going to be given. Today, we know that lung cancer has many molecular subtypes, and there are over 8 approved treatments based on what is the mutation. So commonly, EGFR might be mutated in 14%, BRAF and others, MET skipping, KRAS. Each one of these are often mutually exclusive, and they define a different treatment. You can't get the treatment unless you get the sequencing. If you mix up the sequencing, you give an EGFR treatment for someone with KRAS, you'll actually get a worse result. So sequencing is extremely important in accurately classifying the tumor and selecting therapy. What this means now is every lung biopsy needs to have multiple genes sequenced. Back about 15 years ago, it meant that we had to take a piece of tissue, sequence it for ALK, take another piece, go to NTRK, take another piece, go for EGFR, and so on. So we would run out of tissue. So now with the highly multiplexed analysis, we're able to determine all of this at once. Another technology I was going to show you is that this is a lab in a box. So this is a microfluidic lab where a small piece of tissue can be put into this little cassette, and basically you can get a result of the molecular phenotype within 2 hours, so that we can quickly give a result to an oncologist about what molecular features are present. Currently, it's taking 4 to 6 weeks to get results back. Also, the new technologies with multi-gene panels. This is called genomic comprehensive profiling. And using this technology, we can analyze hundreds and hundreds of genes from a very, very small sample. So this means that a piece of tissue from a lung cancer can be analyzed for over 100 genes. And then this actually enables the doctor to consider well over 100 different therapies that whether a patient might be eligible for. So doing this one test, which is like running a mini human genome project, can help an oncologist decide what drug a patient should use. Unfortunately, these tests are not getting broadly used. It's because payers don't really want to pay for them. They think they're experimental, even though they're not. And the availability of them is that there are very few centers are able to run them. So there's a massive barrier in getting access to these tests. However, patients with advanced cancer definitely should consider getting these large panels done because it can qualify them for special treatments and also for clinical trials. So that's where, again, it's important for a patient and their advocates to really press for multi-gene panels. So these are not in the future. These are here and now. These are available for any patient who has cancer, and it helps them qualify for therapy. Now, hereditary cancer is also important in that over 20 to 30% of cancers may be due to an inherited gene defect. Back 5-10 years ago, we only knew about a few inherited genes, BRCA1, BRCA2, but now there are hundreds of inherited genes. So one of the issues are different companies sequence different numbers of genes, so that if you did have a test done, you might have only had a subset of genes sequenced. So if the result came back, you know, I was tested for genetics and I was clean, well, they may have only tested 10 genes or 20 genes. So more and more now we're considering running whole exome sequencing, where we really look at every gene to determine that we're not missing anything. And at Protean, we're very committed to looking at all of the genes and really doing a complete analysis of all of the genes. Now, another thing that's quite interesting is something called liquid biopsy. And this is where we can now do a blood test to measure what's going on in a cancer in a patient, particularly if a patient has metastatic cancer. So this scan is showing an image. Every dot that's lit up is actually a metastasis from a tumor, so that there are multiple nodes that are involved. It's in the liver, it's in the lung. So it would be impossible to biopsy all of these. These tumors are leaking things into the blood. So they're releasing cells, they're releasing DNA, they're releasing exosomes. So from a blood sample, we can actually measure what's going on with the cancer. So if there is no tissue available, we can do a blood sample and measure what is going on with this patient. We can perhaps even before a patient gets cancer. So the cancer journey is a long one. Cancer may even begin before you're born, in the sense that if you're born with a predisposition to cancer, knowing your genetics may help us identify what sort of cancer you're going to get and what age you're going to get it. And then before cancer is clinically diagnosed, screening is possible. Once the cancer becomes larger and is surgically removed, we may be able to follow that cancer afterwards and determine, was the cancer completely removed or is it coming back? When it comes back, it might change. So taking another blood sample allows us to determine, is the cancer the same one? Is it changing? Does it need a different treatment? And cancers are much like ecosystems in that they disrupt, they change. You give them a drug, they become resistant, different clones emerge, you need to change the treatment. Interestingly, sometimes they go back to a previous version. So a drug that stopped working a year ago might now start to work again. So using liquid biopsy allows us to monitor what's going on with the patient over time. We can determine, do they have cancer left? Is the cancer changing? Is it responding to treatment? Is this treatment futile? Should we try a different treatment, et cetera? So liquid biopsies are going to become more important. In summary, cancer diagnostics are becoming more and more important, or becoming more and more complicated. They're essential. Diagnostics are essential for selecting the right therapy for each patient. Now, remember, because they're complicated, patients may not necessarily get the correct diagnostics. Really depends if their physicians have selected the right diagnostics and if they're available for those cancer patients. So that's one of the things that we're trying to do in our mission, is try to make accessing diagnostics easier so that really every patient and every doctor can easily get the diagnostics they need, so that their patients have all of the information necessary so that they can get the right treatment. Pathology review is also very important because, as I told you, primary pathologists may be very good, or they might not be an expert in the field. And if that's the case, you definitely may want an expert to review your case before making a life-altering decision about surgery or complicated treatment or so on. So pathology review is extremely important. And I can tell you, when I worked at major academic medical centers like at Moffitt, every cancer patient that was admitted to Moffitt from outside would get a pathology review even before treatment started, even before they turned up at the hospital. So the pathology review helped determine, is the diagnosis correct? Is the staging correct? Were all of the tests complete? So that when the patient turns up, that all the information is there, and so that the doctor is ready to treat that patient in terms of knowing, is it mutated? Is there a clinical trial appropriate, et cetera? We found that up to 40% of the time, the pathology review changed the diagnosis or added new information. Genetics is also becoming more important for cancer therapy. We used to think that only maybe 4 or 5% of cancers were driven by hereditary factors, where now it's becoming apparent that maybe 30 or 40% of more of cancers are driven by underlying genetic factors. And a genetic analysis is actually probably indicated in almost every patient with cancer, particularly those with ovarian cancer, with breast cancer, prostate, pancreatic. Probably every patient should be entitled to a genetic analysis, because if an underlying defect in a homologous repair gene is identified, that patient would qualify for a PARP inhibitor and generally do well on it. If a microsatellite instability was uncovered, that patient would do well with an immune therapy and so on. So the genetics is becoming more important. In addition, the genetic analysis may reveal other conditions. For example, whether a therapy might be toxic in a patient in terms of pharmacogenomics, or if a patient might be prone to getting something like a cardiac problem down the road. The other thing to know is that cancer is a 4-dimensional disease. So cancer in different parts of the body are different. That's the 3 dimensions. The 4th dimension is that cancers change over time. So once you get treated, the cancer can actually change. It becomes resistant. It perhaps offers new treatment opportunities. For example, many patients with breast cancer are told they're HER2 negative. However, if you look at the blood cells, the cancer in the blood, turns out that they're changing into HER2 positive. If you're to do that monitoring and put those patients on anti-HER2 treatment, they'll actually do much better than if you don't give them anti-HER2 treatment. So this is illustrative that cancers will change, and this really shows the value of liquid biopsy. In the future, and currently, there are many, many more clinical trials that are open and that are being developed. Often the only way to get onto a clinical trial is to have a genomic profile done, so that you know what's happening with your cancer, what are the mutations, and having that information available helps qualify you for entry onto a clinical trial. Getting onto a clinical trial is a good thing, that basically it opens up new treatment opportunities, and generally patients on clinical trials do very well, or they do better than patients who are not on clinical trials. So key points: second opinions on diagnosis are important. It's up to a patient and their loved ones to consider that. The field is changing quickly. It's important to keep up. There are many new tests coming on to becoming available using DNA analysis, blood, urine, and genetics. These can be very, very helpful in determining what is the correct treatment and if you're responding to treatment. In addition, many of these tests are now covered by insurance, but they're not being used. So being aware of their existence is important. It's also important to know that clinical trials are important and that they have high value. Getting onto a clinical trial is a good thing. It allows you to have access to innovative therapies, perhaps therapies that are really coming out that are curative. And also, even if you're on the standard arm, the quality of treatment is better. Often there will be a crossover, so some patients are concerned that they're only going to get the standard treatment, that they're not getting the experimental. Generally, if there's progression, the standard arm will cross over to the experimental arm. But there are many trials available, and it's important that a patient understands how the trial works so they can ask questions of their providers and so on, so that they have full understanding. The other thing that's important is to really understand that as a patient or a loved one of a patient, that you're entitled to have your results and as much raw data as possible. That I would advise that you get your results, take ownership of it, get the raw data. This allows reanalysis, because sometimes you might only get a PDF report of a genetic analysis. If you're able to get the raw data, it means that an expert can reanalyze it, or there's new bioinformatics software become available that can also reprocess it. So get your results and keep them. They're of value to you, they belong to you. And then it's very good to get an advocate or guide that can help you through the process, because we understand that if the cancer is a terrible, troubling condition, there may be episodes of sickness where it's very hard to advocate for yourself. So having a guide or a loved one is very important. And certainly at Protean, that's one of our visions as well, to be able to help patients through this journey. So precision oncology is definitely a reality. Every patient is unique and special. There's a huge number of tools that are now available to improve the patient journey with cancer, to help link patients with more effective treatments, avoid toxicity, and really hopefully get better outcomes for those patients. At Protean, we're here to help. If anyone's interested in our services, here's the contact information. And it was a pleasure speaking to you today about recent advances in diagnostics, and also how these advances are now becoming available to patients everywhere across the country, around the world. Thank you for your attention, and I can stop and see if there's any questions.
Thank you so much. That was so informative. I have a couple of questions here for you, Dr. Magliocco. How much of non-smoking related lung cancer do you think is due to radon exposure? And are those cancers genetically different or require different treatment?
Yeah, I'm not an expert on radon, but radon is one source of naturally occurring radiation, and it probably is a driver of certain types of cancer for sure. So there are other sources of radiation as well. Cosmic rays, actually natural, even within your own bones, there are radioactive elements and phosphorus that decay and so on. So there are many natural sources of radiation. If you're in a high radon area, that's certainly a risk factor, but there are other factors as well in terms of risk that can drive arsenic. Other types of toxins in the environment can drive non-smoking related cancers. And also hereditary predisposition, in that if your DNA system can't repair errors effectively, that you'll be at greater risk as well. They definitely have a different mutational profile. So typically carcinogen-induced cancers, you'll often see mutations in genes like KRAS, whereas in the more non-carcinogen-induced cancers, you'll see EGFR mutations and other types of mutations. So there are fingerprints that we're learning about. So the genetic analysis might actually be able to tell you what drove the cancer. And that's sort of interesting in occupational exposure, in that some exposures leave a fingerprint, and that can help, if there's litigation, was this cancer caused by exposure to a certain chemical or a certain situation? It's a great question. Thanks.
Can a cancer patient request these specific tests?
Yes, absolutely. A cancer patient can take care. They can request tests. They can get second opinion. They can contact us. We have many private patients that come to us and ask us to work with them. Often we'll go back and work with their medical team. Their medical team may be unaware that certain tests are available, and they're happy when we get back to them to share results with them. So yes, a patient can definitely request tests and take care of their own testing journey. And in fact, it's always advisable for a patient to be aware of what are their options, what do the results mean, because in those cases, they'll really understand what are the pros and cons of each treatment decision that's before them. So I strongly recommend the patients actually get more involved in their testing. Why is the test being done? What do the results mean?
Is it very difficult to get doctors to work with your company? I mean, do people typically need to come to you privately?
It's variable. So some doctors are somewhat skeptical, but once they get to know us, they realize, we're a very legitimate company. We're very experienced in this field. We're collaborative. We're not out here to prove people wrong. We're really here to fill the gaps. We're here to work and help them. So generally, we'll try to connect with them, and in most cases, they'll work with us. And then they actually say, "Wow, this is a very effective service. I'd like you to work with more of my patients and send more patients to us down the road." So our goal is really to make this information more broadly available and access more broadly available. Like I say, sometimes a patient will have, for example, we had a patient in Australia that ran a KRAS test, and they were told there's no actionable mutations there, which we reanalyzed and said, wow, it's actually got an inherited mutation for that would qualify for a PARP inhibitor, and another one for a PIK3CA kinase inhibitor, and actually had a PDL1, and that patient went on to a clinical trial and is doing very well. And so sometimes you don't even have to do additional testing. Reanalysis of existing testing can be very helpful in uncovering new treatment opportunities, because those trials might not have been open 3 months ago. Now they're open, or people didn't recognize, wow, these genes are actually important. They do drive a response to certain drugs. So getting a reanalysis of the existing data can be very valuable. And then new tests are coming on all the time.
And you mentioned earlier about how cancer can mutate after treatment. I don't know that that's happening much, where people's cancer is being reevaluated after treatment is finished, especially if there's no evidence of disease. So maybe there is no reason to go back and monitor at that point. What do you have to say about that?
So typically it depends. So if a patient has metastatic cancer, you can actually monitor it with the liquid biopsy and repeated biopsy. If a patient has gone into remission, for a period of time and the cancer has recurred, I would strongly suggest that it's biopsied and reevaluated, because they might have a brand new cancer that's completely different from the other one, or the cancer is changed in a substantial way. So they might have had breast cancer that was ER positive, now it's negative, might have been HER2 negative, now it's positive. So it's extremely advisable that if there's a recurrence, that it be retested, because you want to treat the current cancer, not the one from 10 years ago. We also say we don't want to treat the cancer that's in the bucket in the lab. We want to treat the cancer that's in the patient. So that's where the blood test comes in. What's going on with the living cancer inside that patient? Is that cancer responding to treatment? Is it changing? And also, like I said, it's a bit like an ecosystem, because a cancer is made up of millions of cells, and you can kind of think of it, each drug disrupts it. So it's like in an African ecosystem, you might kill off all the elephants, and now the hyenas are out of control, but over time the elephants may come back in, and the hyenas go away, and you can reuse the drug again. So cancers tend to go back to their original condition. So over time, there is this dynamic where they change and then they go back again. So you can imagine treating them as pushing them out of their comfort zone, and then they want to go back to normal. So they'll generally go back to kind of normal again. And then this gives an opportunity to reevaluate and reconsider treatment again. So cancer is very dynamic. It changes and so on. And we're starting to learn that a treatment that might have failed 3 years ago might now be effective again. So cancers may go back to previous states in an individual. In addition, overtreatment can sometimes lead a cancer to develop resistance. And we're starting to learn about the evolutionary dynamics, so that if you don't actually overtreat a cancer, you can put a cancer to sort of sleep, and you may keep it asleep for much longer than if you pushed it into resistance. And there's some innovative work about that. How do you put the cancer to sleep in terms of not giving it maximum treatment, but actually adjusting the treatment so that the cancer stops dividing, it becomes sort of stable. If you overtreat it, it kind of can tip it into a crisis where then a super malignant clone emerges. But if it's existing in a more quiescent state, it can stay stable for a much longer period of time And some of the evidence shows that you can use a quarter of the amount of treatment and get more than double the outcome. So that there's a lot of work in terms of how do we properly dose cancers and keep it in optimal state.
We have a couple of questions or just statements about second opinions. How does someone go about getting a second opinion? Does that combat the issue of a bad pathologist, I guess?
Yeah, I would say a second opinion is really important, that one should ask for it. It's not necessarily a bad pathologist, it's an inexperienced pathologist, because when you have an expert, like I've looked at, I don't know, I counted over 55,000 breast cancers in my career, whereas some may only see a dozen or 100. So after you've looked at thousands and thousands of them, you become more experienced. So having an experienced person can, pick up deficiencies and so on. So it's not necessarily they're a bad pathologist, because most of the pathologists are qualified, but they may have different areas of expertise. They might be really focused on blood cancer, and you happen to have a breast cancer and so on. So getting a proper second opinion is really important to make sure that the diagnosis is correct and that the diagnostic services have been done completely, et cetera.
This is a question about financial options, especially if someone's going to come to you outside of the care that they're receiving. Do you know of any financial options patients can take advantage of to do a multi-gene panel when insurance doesn't cover it?
Yeah, there are different price points. So we have different price points that a patient can get onto. There may even be clinical trials where the cost of the testing is free. And so they can potentially have that as part of the clinical trial eligibility. There's also payment plans, and we're also working with foundations that provide coverage for people who don't have coverage. So there's certain breast cancer foundations will pay for patients for testing and so on. So there's many different mechanisms, and that for patients who are economically disadvantaged, the company also has programs to allow them not to be charged for testing or to have a reduced amount. There's certain compliance issues in the US about how you price testing, but the main ways to go at are payment plans, economic hardship, that there's reduced pricing, foundations that can support it, and getting onto clinical trials that support testing. And in addition, there may be different testing options that are more limited but are equally effective at a lower cost. So there's a variety of options for testing.
Great, thanks. I think this last question we have here is along the same vein. Can we get a list of these tests with costs, benefits that we can share with others? And then it's the same question, are they covered by insurance?
Yeah, typically almost all of the testing is covered by insurance because these are medically necessary tests. Mm-hmm. It's a matter of really pushing insurance to pay for them, because these are indicated by guidelines. They're used to optimally treat patients, get them onto the right treatment. It actually saves insurance money in the long run because it avoids being treated with treatments that are futile or potentially toxic, and really matches them to optimal treatment outcomes. Certainly you can work with us to get the list of pricing and so on, because it really depends, because in some cases, no additional testing is necessary, that the tests are there. Basically, it's really a matter of a review. It may cost a couple of $100s or so to do the review, get that back, or else a more comprehensive panel is required. That may cost a few $1,000s to have those more comprehensive panels done. So it's fairly variable between individuals, but happy to have a discussion about sort of the cost ranges and the options. And in fact, there are thousands of tests, so couldn't possibly list them all, and there's more and more. So the fact is, you have to kind of, it's like cooking, that there's many different ingredients, and you have to put the right one together for the right package for the right patient. And so depending on the price point and all those kinds of things, we can optimize testing to really get the most efficient sort of bang for the buck, in terms of if there's only a limited amount available, you do the high priority test first and so on in terms of that.
Great. Well, thank you so much. I don't see any other questions. So thank you very much for joining us today. We really appreciate your time and expertise. It's been very informative and enjoyable.
Well, thank you so much for inviting me. A pleasure to work with you. And if anyone's interested in speaking with me directly, please feel free to contact me. Thank you
Great.
so much. Take
Thank you.
care. Thanks. Bye-bye.
So thank you again for joining us for today's Cancer Wellness Symposium. A survey will be sent to your inbox, and we appreciate your feedback as we plan for future events. Our contact information should be up on the screen. Yes, there it is. If you have any follow-up questions or would like to reach out to LifeOmic or Karuna Precision Wellness Center, you can please do so. A copy of today's symposium will be sent to you shortly. Thank you so much for being with us this afternoon, and have a great rest of your day.